Good morning, everybody. Welcome back to the session of RapidMiner. So yesterday we have started discussing about this RapidMiner. So let's have a quick recap of what we have discussed yesterday. So we have seen yesterday the intro, first of all, what we have discussed. We have seen the introduction to RapidMiner. Before going into the intro of RapidMiner, we have also discussed about what is data mining, what are the different tasks present in data mining, and also what is the meaning of no code development platform. We have seen those things, and later we moved on to the introduction to RapidMiner, and we have seen what are the various products present in RapidMiner, and we have also installed RapidMiner Studio. We have seen every bit, like how to download, how to install, and how to set up that particular product, and what are the features present in RapidMiner Studio, and how is the interface looking like. Like what are the components present, and what is the purpose of each and every component. We have seen everything. And also in RapidMiner, as we have discussed yesterday, we have some inbuilt data which is already present. So how to use the inbuilt data, and also how to just import the data that you want from the local machine. We have seen these things. So today let's discuss about the further things, which is EDA and data pre-processing. So you already know about EDA, you already know about data pre-processing. So we will have a quick intro of all those things and how to do each and every step in RapidMiner Studio. Okay, so we have seen data mining, which is used to uncover the patterns from vast amount of data. And no-code development platforms are nothing but the software tools which are useful for any user, whether he is a developer or a non-developer, to perform various tasks regarding data mining or to create the applications without writing any code. And RapidMiner is one of that tool, which is a no-code development tool. And this is one of the most popular data science tool. And it can be used in various purposes. And these are all the different products present. Within these, we have installed yesterday RapidMiner Studio. So within that, there is an incorporated auto model as well as turbo prep present. We have seen those things as well. And we have also discussed what are the advantages of RapidMiner present, and also we compared the advantages along with the disadvantages. And also we have seen how we can use RapidMiner in industries and what kind of data sets RapidMiner can process, like structured data, unstructured data, or a database, or NoSQL system, or is it a cloud storage device? Whatever the data may be, the data can be processed with the help of RapidMiner. And then we have seen the steps of downloading the RapidMiner Studio. So if you have missed it, you can just go and watch that session, which we have done yesterday from 9 to 1. And this is the downloading part. After completion of downloading, we have also discussed how to install that application. After installing, we have to set up that application. Once everything is done, your application window will look like this. So here you can watch the tutorials if you want. Now, after that, we have also seen what are the features present in that particular RapidMiner Studio. So there is a drag and drop interface, which we have seen, and there is a rich operator toolbox for every particular task. There are some pre-built operators present. We have also seen this. And we can integrate with different types of data sources using import data option or read operators present in the operator component. And it can handle large data sets. That is why there is one more feature, which is scalability. And we can also deploy predictive models. So here, one of the other feature is model deployment. And what else? So the components or the interface of RapidMiner consists of different components. First one we have is repository. So let me open my RapidMiner Studio. We will see that there. So this is the RapidMiner Studio, which we have installed yesterday. Let me open this one. Just give it a second. Just give it a second. Okay, it is taking some time to open. Okay, in the meantime, we will discuss about the components over here. So what are the different components present? So the components that we have is, first one we have repository. Repository is nothing but we have to create flows, workflows, or we have to store the data, or we have to store the process. All of those things can be done with the help of repository. And the second one we have is operators. So operators component, it is used to perform, or it is used to have all the operators in order to perform all the tasks. Like in order to clean the data, we have some special operators. To build the models, we have special operators. To access the data, we have special operators. For validation, for all these purposes, there are some pre-built operators present, which is present in the component, which is operators component. Next one we have is parameters. Parameters is useful to customize the operators. We have seen all these things yesterday. And also views, we have design view, results view, auto model view, and turbo prep view. So design view is useful to design any process or the workflows by connecting one operator with another. And results is used to display the outcome of the process that we execute. An auto model is useful to build the predictive models, whereas turbo prep view, it is useful to clean the data. So these we have seen yesterday, and also how to use the pre-built data and how to import the data. And also we have imported the data from a CSV file using two options. One is here, you can see the import data option present in the repository panel. That is the one thing that we have done. And also, under the operators, you have data access, within which you have read Excel and read CSV, all those operators present. So you can use either import data or read operators to get your data set. But we have also seen the difference between the two. So this one, the import data option, it is useful for storing that in the local repository or the repository that we create in RapidMiner Studio. Whereas when we use read operators to load the data, it will not be stored in any repository. So that is the one difference that we have discussed. So let us now talk about a few common operators that we can use. So this is how your RapidMiner Studio will look like. Yeah, sorry. So this is how your RapidMiner Studio window will look like. And here you can see the repository is present. Here, if you want to create a new one, you can create a new one here. And if you want to just get the access of any operator that you want to use, you can search it here or you can see it under here. Okay, so now let's discuss some operators which we can use like for simple purposes and all. So first of all, any operator that you want to use, if you want to see the purpose of every operator or the description of every operator, for suppose we have here maybe files, you have read operators here, and what is the purpose of read CSV operator? See, you can hover your mouse button over here or right click and F1, which is show operator information. So when you click on it, you have description present. You can read the description of every operator like this. Right click on the operator and get the information and description. So this operator reads an example set from a specified CSV file. So if you want to get the data from a CSV file, which is not pre-built or inbuiltly present in RapidMiner Studio, you can use this operator. So let us see some sample examples. So we have a data set which is education data set. So let me open that data set for you and show it to you. So you have education data set present. So this is present in here, I guess. So this is the education data set that is present in my documents. Maybe you have already used it in your previous like whatever the products that you have used or tools. Maybe you have seen this data set. Let me open it for you and show it to you. I'm going to use this data set to perform some actions using some operators in RapidMiner Studio. So this is the education data set. This is a CSV file and it is having 3 columns. One is data serial number and work experience and GMAT scores. These are the 3 columns present in my education data set. I'm closing my data set over here. Now I'm going back to my RapidMiner Studio. Now I have to get the data of education CSV file into my RapidMiner Studio. How to get it? Either you can use import data or you can use read CSV. I don't want to store it in my local repository or any repository, so I will simply use my operator. So I will drag this operator and drop it within the process. So process is where you can see all the sequence of steps. And design view, this is where we can create the process or the workflow by connecting one operator with another operator. So this is the basic purpose. Now, in order to get the output, what we discussed yesterday, in order to see the data set, whether it is properly loaded or not, we have to connect the output port to the response port. So here the out is present, right? You have to connect it to the response. And after that, you have to click on this play button, which is run or execute. Once you do this, so here, we did not see the data set, right? We did not load the data set. Now, I'll cross this one. So I will load the data set first. So double click on the read CSV operator. Now I want to load education CSV. So I've selected education CSV and I'll click on next. Once I select the data and click on next, it will ask me whether I want to format my data or not. So see, if you want to have the header row, you can keep it. If you want to have a comma separator, you can just write it over here. I don't want anything. I don't want to change anything. So I'll simply click on next. After that, if you have anything else, date format, anything to change, you can change it here. I don't want to change any data type. So here you have options like change the data type, change the role, renaming the column and excluding the column. You can format your columns if you want, or else you can click on finish. Once I click on finish, I got my data loaded or read into my operator over here. Now I want to execute the process. How to execute it? I want to connect the output port to the response port. And after that, I have to execute it. Once I do this, you can see in my education data set, which is a CSV file, I got totally 773 records and 3 columns. So what are the 3 columns? One is data serial number, second one is work experience, and third one is GMAT. So these are the 3 columns present and the number of records are 773. So this is how you can load the data using the read CSV operator. And what else? As we have told, the outcome can be seen in the results view over here. Now, if you want to go back, you have to go to design view. So this is results view and this is design view. And after that, what can we do? So we can perform various actions using different operators. Now let me show you few of the operators and what is the purpose of it. So I will search for the operator which is select attributes. So here see, I will show you the description. Right click, this one and description. So this operator, it selects a subset of attributes of an example set and removes the other attributes. So basically the purpose of the select attributes is here this operator allows you to choose which column you want to include in your analysis process and which columns you want to exclude. So I'll show you that as well. So I will simply drag this and drop it here. What is that, everybody? I am going to use the operator which is select attributes. I'm going to drag it and drop it over here. Now what to do? So here, after dropping it, you have to first connect the data to the operator select attributes. The output of the read CSV operator should be connected to this particular port of select attributes, which means the output of this operator will be the input to select attributes operator. Now what to do? Now we have to customize our operator in such a way that I have to choose only few columns. I want to get only this column in my analysis process. Remaining columns, I don't want to use it for analysis. So if you have such type of requirement, you can go for select attributes. Now, how to customize? As we have talked about this before, in order to customize an operator, you have another part or component called as parameters. So click on this operator that you're going to customize. Here you have parameters coming for select attributes. Now what to do? You can see here, you want to include the attributes that is nothing but columns or exclude them. I want to include. Now, how many attributes you want to include? All, or I want to include one or a subset or types of values or no missing values. So basically we will go for all attributes or one attribute. So I want to choose only one. If you want to choose two, you can go for a subset. I want to choose only one column out of three. So I'm going for one attribute. So what is the column that I want to keep for my analysis process? I have to choose it here. Either you can go to the drop down or you can just manually write it. I want to select here GMAT. So out of the three columns present in my education CSV file, I want to take or select the column or attribute that is GMAT. Remaining columns I don't want for my analysis process. Okay, I have customized my operator select attributes using parameters. Now what to do? If you want to get the output, you want to see the output. So you have to connect this particular port to the response port. So you have to connect the operators, and after connecting all the operators, you have to connect the output to the response. Only then when you execute, you will get the output. If you don't connect it to the output port, you won't get the output. So here I will execute this one. Now you can see here, out of three columns present before, I got only one column. So see here, there is one attribute and 773 records. So basically read CSV is useful to read any CSV file from your local machine onto this RapidMiner Studio. And the second one I have used here is select attributes. Select attributes is useful to choose whatever the columns that you want to include in your analysis process or whatever the columns that you want to exclude in the analysis process. So those customizations can be made using the parameters components. And after that, you have to make the connections between the operators. And after connecting the operators, you have to connect the last operator output to the response. Once you do that and execute it, you will get the output based on your selection of columns. I have selected to include only GMAT. So my table is having only GMAT. This is the purpose of select attributes operator. Now what else? So I'm going to use one more operator, which is filter example. So we will see the description of filter example. So here, this operator selects which examples of an example set are kept and which examples are removed. So here we will see what is filtering does and what is the purpose of this operator. So this is a drag and drop interface we have seen yesterday. Just simply drag this and drop it here. After dragging and dropping, what you have to do? You have to again make the connection between the operators. So the output of select attributes will be the input of filter examples. Now what to do? Now we have to customize our filter examples operator. How to just customize this operator? By using the parameters. So click on this operator. You have on the right hand side add filters. Click on add filters. Now what you want to add your filter? So I want to add the filter like the GMAT scores should be greater than 700. So I want to show the records of the GMAT scores only which are greater than 700. If you want to add further condition, you can add the entry over here. I will simply click on OK. Okay. So after doing this, I have added my filter. Now I want to get the output. How can I get the output? I have to connect my output of filter examples to the response port. Once I do this and execute it, I will get the output So out of 773 records before, I got now only 511 records. Why? Because remaining records are not having the GMAT scores which is greater than 700. So if you want to change the condition, you can go over here again and change it to maybe 720. Okay. Now I will execute this again. Here you can see there are only 229 records. So before it is 511 when it is 700. But when I've taken to 720, it is only 229 records. So based on the conditions, if you want to perform any action, you can go for filter examples. So filter examples will filter the records based on the condition that you have provided in the parameter of that particular operator. So read CSV to read your CSV file, select attributes to select your columns that you want or you don't want for analysis, and filter examples to filter the records based on the condition that you provide. So these are the basic things, everybody. Now I will show you one more thing. If you want to delete whatever that you have written, what you have to do? So click on this and delete. Click on this and delete. This is simple, or you can choose everything in one go and delete. Anything is fine. Now I have education data set. Now now I will execute it. You will have again 773 records. See, again I got 773 records. So out of these 773 records, I want to pick only a few records. Okay, not based on condition now. Out of all the records present for all the columns, I want to choose only few records. So for that, we have one more thing or one more operator, which is nothing but sample. You already know sample. We will talk about this in inferential statistics as well. So sample, I'll take it over here. You can directly write it like this, or you can connect it also. So what is the description of this operator? So sample operator creates a sample from an example set by selecting examples randomly. The size can be specified on absolute, relative, and probability basis. So here this is the sample. Now what you have to do, you have to customize this. So I want totally out of 700 records, I want only 500. So I'm keeping this to 500 the size, and now I'll execute this one. You got here, see, 500 records and 3 columns. So sample will pick how many records that you want that you have specified in the total population. That can be used with the help of sample operator. Now what else? What else are other operators that we can use on daily basis or whenever we are working out like this? So you also have sorting thing. So if you want to sort your data, you can sort it. So here I have sort. So I will take the sort. Either you can do this, or what you can do, you can take it anywhere in your process and you can connect it manually. Whatever is comfortable for you, anything is fine. Now what you can do, I have to customize this. How? Click on this operator. You have got parameters on the right hand side. Click on the list that you have. Okay. Now what is my requirement? I want to sort my data based on the GMAT scores in descending order. I want to sort entire data based on the GMAT scores in descending order. Now click on apply. If you have any more thing, you can add it. I don't have any more thing. I'll click on apply. Now what you have to do, connect the example or output to the response port and execute it. Now you can see the GMAT scores highest from lowest because I have taken this in descending order. So when I just scroll to the bottom, it will be the least GMAT score, which is 600. So that is sort operator. Sample to choose sample number of records from the total population. Sort based on the condition, based on the column, based on the type of sorting that you want. It will sort the entire data. So these are the different things present. And you can also go for aggregate. I'll show you the aggregate also later. So these are the different operators present. If you have confusion of what operator is used for which purpose, if you don't have idea about an operator, you can simply go for description. So shuffle is there. I don't know what is the use of shuffle. So I'll go and see the description of this one. So this operator creates a new shuffled example set from the given example set by making a new copy of the given example set in the main memory. So shuffle operator creates a new by making a new copy of the given set in the local random memory or the main memory. So you can see the description, you can see what will be the input, what will be the output, and you can see the parameters, how to customize it, everything under the description. If you want to see the tutorial process, you can see it in this. So we already have Fish's iris data, right? You can see this tutorial process and you can use it on the data. If you want to open it, you can open it. I don't want to show it right now, so I'm not opening this one. Okay, these are the basic operators that you can use when you are working in RapidMiner Studio. Now, let's talk about the next thing, which is EDA and data preprocessing. So before going into EDA and data preprocessing, maybe we will see, first of all, what are the various steps present when we are working in a project. So let me go back to the browser where we have our 360DigiTMG mind map. So here you have various stages present in project management methodology, which is CRISP MLQ. You already, I think you are aware of it. So let's have like a discussion about everything and we will move on to the data preparation, the most important part. Okay. So first of all, when you are working in a project and there are a lot of steps present, the first and the foremost thing that you have to do is business understanding. So what is there in the business understanding? So when it comes to business understanding, first you have to record the business objective, you have to record the business constraint, and you also have success criteria. If it is a DA project, which is analysis project, you will have two success criteria. One is business success criteria and second one is economic success criteria. But when you are working on a DS project, which is the data science project, you will use machine learning there. So you will have three different success criteria. One is business success criteria. Second one is machine learning success criteria, which is ML success criteria. And third one is economic success criteria. So it is always recommended to you to write the business objective and business constraint using 2 to 3 words. And also, what are those words? It is recommended to use the data optimization terms like minimize and maximize. So minimize the sales, maximize the sales, all those words should be mentioned with the help of these data optimization terms. And the next thing that we have is project charter. Project charter is the first document which gets prepared on any project. So what is that document having? This contains details at a high level about high-level product characteristics, high-level project requirements, summary budget, who are the key stakeholders, what are the risks present. All of these things are mentioned in that particular document. So this document is signed by the project sponsor. If you want to see more of all these details, you can refer to the blog as well. So right now we are having just the basic understanding to move on to the data preparation. So that is why we are having some knowledge about the business understanding. So business understanding, what is the main thing? You have to record your business objective, you have to record your business constraint, and you also have to record your success criteria. So as we have seen, if it is a DA project, you will have two different success criteria. One is business and second one is economic success criteria. If it is a DS project, you will have business, you will have economic success criteria, and you will also have ML success criteria. And after that, what is present? You also have project charter, which is the first document that gets created on any project. And it will contain a details of a lot of things like budget, key stakeholders, the milestones, what are the risks present. All of those things are mentioned within that document. And also you have to remember, when you are writing your business objective and business constraint, you have to write it in only 2 to 3 words, which is the most suggestible thing to do. And also those words should be starting with the data optimization terms, minimize and maximize. So this is about business understanding. Next, what is that? After completion of this step, you have to go to the second one, which is data understanding. So coming to the data understanding, you have here again two different types. One is data type and second one is data collection. You already know about the data collection. You have primary data sources and secondary data sources. So primary data sources are nothing but the data which is collected at the source level. Like if you are collecting the data through surveys or through web scraping or through social media extraction, all of those comes under primary data sources. And secondary data sources is the data which is already available, which is nothing but open source data. So this is easily available. This is to get the data which is from the primary data sources for the exact variable of interest is the pro of this one. Here we may not have variable of interest data. So because this is already available data. So this is costly and this is time consuming. Here the data is easily available. So these are the data collection steps which is we will do in every project. Like whatever the data that we are collecting, we have to understand whether that data we are collecting, is it from primary data source or is it from secondary data source. And also after collecting the data, you will have the columns, rows, all of those present, right? You have to understand what is the data type of each and every column present in your data. So whether it is a continuous column or whether it is a discrete or it is having these different types of data types, you have to understand. So let's have just a normal discussion about everything. So what is continuous data? So the data which can be represented in decimal format and which makes sense is nothing but continuous data. So discrete data is nothing but the data which cannot be represented in decimal format, or you can also say the data, if it is represented in decimal format, it will not make any sense. Like what? Like what? What do you think is the examples of this? So there are of two types again in discrete. One is categorical and second one is count. In categorical, you have again binary and multiple. If you have two categories, that comes under binary. If you have multiple categories, that is called as multiple in categorical. Now, in this multiple, again, you have nominal and ordinal. So ordinal is nothing but having the order. You already know, like jersey number or what we can say, the rank of the class and military rank and size of the clothing. Everything comes under orders. And nominal data, you can see. So this is the least preferred one. So here you have whether it is a male or female, the gender, and what is the color of your shirt. All of these things comes under nominal because they can't be represented in decimal format. And also, even if we represent it, it will not make any sense. And also, it is having different categories. So it comes under multiple. And also, it is not present in order. So this comes under nominal. So this is a discrete, categorical, multiple nominal data. So you have to get an understanding of every data type present under this. So discrete is fine and continuous is fine. And what is qualitative data? So qualitative data is nothing but the data which describes the characteristics, or we can also say the data which cannot be measured numerically. For example, you have examples like feelings or opinions. All of those things we cannot measure in the form of numerical matters. That comes under qualitative data. And what is quantitative? Quantitative is nothing but which consists of numerical measurements. Like what we can take example, maybe the number of sales transactions happened in a month. That comes under quantitative data because that is a numerical measurement. And what else? You already know structured, semi-structured and unstructured, which is present in a proper format, which is rows and columns, that is structured data. Example is spreadsheet, CSV, all those files. And semi-structured is not having any rigid structure like structured data, but it also contains some organizational properties. Unstructured is not having any predefined data model or any organization. So you already know this. Big data and non-big data, you have to know this one. Here it is having the 4 V's: volume, velocity, variety, and veracity. So the big data refers to the extremely large or the complex data or complex data sets that traditional data processing methods struggle to handle. So that is nothing but big data. So non-big data, you already know. Non-big data are the data sets that are not excessively large and that can be managed using traditional data processing techniques. Like a small business customer data, all of those things are non-big data. Okay. And what is this cross-sectional data? Cross-sectional data is data which is collected by observing many subjects at a single point in time. Like we can call it as maybe the data which is collected through surveys from various households. That comes under cross-sectional. Okay, the data that we are collecting through the surveys from different households, comes under cross-sectional because we are collecting the data by observing different subjects or many subjects at a single point in time. That is called as time series. So here you will have cross-sectional in which the date and time in which you have the data does not matter. Time, it matters. That is the only difference. And then what? Balanced data and imbalanced data. So balanced data sets. So here, these refers to the data set where the number of observations in each category is approximately equal. So imbalanced is the opposite of balanced, and offline or batch data versus live streaming data. Offline is nothing but the data which is collected and processed in large batches at scheduled intervals. Like what? Maybe there is having a weekly report which is generated for the historical sales data which is already there. This is offline data. So live stream data is nothing but, I will give you an example of live stream. So there is this stock market data streamed in real time rate that comes under live streaming data. So you have to understand what are the different data types present and what is the purpose of each and every data type. You have to get an understanding. That is when we will move on to the next step, which is data preparation. So what we have discussed up to now, I have shown you what are the different operators present in RapidMiner Studio. And out of all those operators, what is the description of every operator, how to see them. And also, I have shown you few operators like select attributes, filter examples, sort, sample. All of these operators, we can connect one with each other and we can just get the output as we desired. So how to customize those operators? By using the parameters. Okay. And the next topic that we have is EDA, which is exploratory data analysis or data analytics. So before discussing or going into the data preparation process, we have to get an understanding of the two steps present before that. One is business understanding. Second one is data understanding. So business understanding is nothing but business objective, constraint, and the success criteria. Whereas data understanding is nothing but data types and data collection. Now coming to the third one, which is the important one, data preparation. So what is data preparation? What can we discuss under data preparation? So let me open the third one, data preparation. So in this step, data preparation, we have three parts again. Exploratory data analysis, which is also called as descriptive statistics. And the next one we have is data cleaning, which is also called data preparation or data munging or data wrangling or data organizing. Any word is same. Now the third one that we have is feature engineering. Okay, now let's start discussing about the important thing, which is exploratory data analysis. Now I'll go back to the PPT, which is already there in your RapidMiner folder in the LMS. So we have seen this first one, RapidMiner, and the second one we have is EDA and graphical representation. So let me go to the second module and open our PPT. So here is our PPT, or here are the slides of this particular module. So this particular module is talking about data understanding. So business understanding is done. Data understanding, within that we are collecting the data. We are having or understanding the data types. Then we are moving on to exploratory data analysis part. So EDA is also called as descriptive analytics, or it is also called as descriptive statistics. So there is a tagline given over here: torture the data until it reveals everything. So when you perform different steps on the data, like data pre-processing, all of those things, you will get whatever that you want from the data. Now what else? So in this particular module, we will cover few topics like what is random variable, what is probability, and what is probability distribution. And then what do you mean by inferential statistics? And what are the measures of central tendency, measures present, and measures of dispersion, and what is expected value, and also graphical representation, which is using bar plot and histogram, and also third and fourth business moments, and box plot, and what is normal distribution, and what do you mean by scatter plot. So all of these things we are going to cover in this particular module. So first of all, what we have, that is probability, probability distribution, and random variable. So let's go to the next slide. So, first of all, in the data preparation, before moving on to the 4 business movements present, we will go and discuss about the probability first. So, what do you mean by probability? What do you mean by probability? So, probability, I can write it over here like probability is a measure. It is a measure. It talks about how likely something is going to happen or some event is going to happen. So like what? Suppose in this particular example, there is already showing here a single die. So that is the event over here. So event is nothing but rolling a single die. Okay. So when we are rolling a single die, what may be the output? What may be the output? So probability is nothing but a measure which talks about how likely some event is going to occur or it is going to happen. So here, what is the event? The event is rolling a single die, which you can see at the bottom. So when you are rolling a single die, what may be the output? What may be the probability of that particular event? That is nothing but the word called as probability. So what do you mean by probability of what is going to happen? So when we are rolling a die, so in a die, you will have numbers like what? 1, 2, 3, 4, 5, and 6. Sorry, 5 and 6. So this is the probability of an event which is rolling a die, the output or these possibilities present. So probability is a measure that is talking about how likely some event is going to happen. So example I've taken over here is rolling a single die. When I just roll a die, the output may be either it is 1 or it may be 2 or it may be 3 and so on, it may be 6. So this is my possibility. Now what is present in the slide over here? So probability is there. This is what I know about the probability. Now what else? So suppose you roll a single die. What is the probability that the outcome be? What is the first case? If the question is bigger than 3. What is the question over here? When I roll a die, what is the probability of the outcome that is bigger than 3? How can I know the output or how can I know the probability of this particular question? So you have to know the formula first that talks about probability. So what is the formula for probability? Probability, how can we calculate is, it is equal to number of interested events divided by total number of events. So you already learned this in your high school or something. So probability is nothing but number of interested events divided by total number of events. Now here, what is the question? So here, when I roll a single die, what is the output that is bigger than 3? So here I have the outputs like 1, 2, 3, 4, 5 and 6. So according to the formula, which is bigger than 3, out of 6 numbers, how many are bigger than 3? 1 is not bigger than 3, 2 is not bigger than 3, 3 is also not bigger than 3, 4, 5, 6 are the 3 outputs which are bigger than 3. So the number of interested events is equals to 3 divided by the total events are 1, 2, 3, 4, 5 and 6. So 3 by 6 which is equals to 1 by 2 which is nothing but 0.5. So the probability that the outcome or output may be bigger than 3 when I roll a single die is nothing but 0.5. This is how you will calculate the probability of outcome based on a particular event. I hope everything is clear up to here. Now we will see what is the other case present. So equal to or bigger than 3. How can we calculate equal to or bigger than 3? Sorry, equal to or bigger than 3. How can we calculate? We can calculate this one. I will write it over here. So bigger than 3 is fine. Now equal to or bigger than 3. So I'm not writing the formula again. Number of interested events divided by total number of events. So what is equal to or bigger than 3? So here 1 is not equal or bigger than 3. 2 is not equal or bigger than 3. 3 is equal to 3. Fine. 1 is fine. 4 is bigger than 3. 1, 2, 3 and 4. So 4 are the interested events satisfying the condition over here and the total number of events are 6. So 4 by 6 is equal to 2 by 3. You can call it as 0.66 something. Okay. So this is how your output is going to be based on a particular condition and based on a particular event. This is called as probability. So probability is a measure which talks about how likely something is going to happen. That is nothing but the formula for the probability over here is number of interested events divided by total number of events. We can take a lot of examples that we want. For suppose the next one that we have is smaller than 4. Smaller than 4 is nothing but 1 is smaller than 4, 2 is smaller than 4, 3 is smaller than 4, but 4, 5, 6 are not smaller than 4. So 3 divided by 6 again it will be equal to 0.5. And what else? Greater than 2 and less than 6 or between 2 and 6. You can call it as. So I'm just erasing this one. So here, what is the next thing that we have? Greater than 2 and less than 6. Like what the condition over here is, the number should be greater than 2 and it should be less than 6. So what are the things or numbers or outcomes that satisfies this condition? So greater than 2. 1 is not greater than 2. 2 is not greater than 2. 3 is greater than 3. And also 3 is less than 6. So 3 is satisfying the condition. 4 is greater than 2 and less than 6. 4 is also satisfying the condition. 5. 5 is greater than 2 and less than 6. 5 is also satisfying the condition. 6. 6 is greater than 2, but 6 is not less than 6. So 6 is not satisfying the condition. So the number of interested events is 3 divided by total number of events is 6, which is equals to again 1 by 2, 0.5. This is how we will calculate the probability. This is how we will calculate the probability over here, which is nothing but the measure of how likely something is going to happen, which is some event is going to happen. In our case, the event is rolling a single die. So in that, I have totally the possibilities of getting 6 outcomes, 1, 2, 3, 4, and 5, 6. Based on the condition, we will calculate the probability using the formula. Probability is equals to number of interested events divided by total number of events. This is how we will calculate the probability. Now, what is there next? What is next? So I'll go back here and I'll see what is there. So this is fine. The probability is fine. Let me delete what I have written. So the probability is fine. Probability is nothing but how likely some event is going to happen, which is measured in the form of the condition, the total number of interested events by total number of events. So that is how we will calculate the probability. Okay, the probability is fine. The next one that we have is random variable. So what is a random variable? Let's see what is present in the random variable. So random variable describes the probabilities for an uncertain future numerical outcome of a random process. So what is this big sentence or the statement given over here? So I am such a girl that I can't get all these statements that is present or having a lot of different sentences. So I don't know basically the probability which I've learned now. We don't know uncertain future numerical outcomes. What does that mean? And what is a random process? So this is a lot difficult to understand. So in order to make it easy, let's divide the word present over here into 2 individual words. First we have is random and secondly we have is variable. So what is a random and what is variable? So here, a variable is nothing but whatever the number which varies. So it is a variable. A random variable is a variable because it can take one of several possible values. It can take one of several possible values. For suppose, imagine when I just flip a coin, I have an event over here and the event is flipping a coin. So when I flip a coin, I'll have possibility of occurring 2 outputs. If it may be heads or it may be tails. That is my output over here. That is the probability of my output. Now what? If you have an event like rolling a die, just like we have discussed before, when I'm rolling a single die, I'll have the probability of outputs of 1, 2, 3, 4, 5, and 6. So this is nothing but an event and the possibility of outputs. Now, what do you mean by random variable? So there is a variable which outcome is varying according to the event. So here, if you observe, what is the probability of heads? What is the probability of heads to occur when you are flipping a coin? When you are flipping a coin, how much is the probability of heads to occur? So we already know about the probability formula. Number of interested events divided by total number of events. So what are the number of interested events? 2 only are there. Out of 2, what is my condition? What is the probability of heads? So head is number of interested events is 1 divided by total number of events is 2. So 1 by 2 is nothing but 0.5. So this is nothing but probability of everything or every output present in a particular event. So this particular flipping a coin event is a variable or it is a random variable because the output, it is having several possible values. So it may be head or it may be tail. When it is the case of single die rolling, it may be 1, it may be 2 or 3 or 4 or 5 or 6. So whenever we have varying possible values to be as output, such variable or such random variable is called as a variable. So variable is nothing but something or a value which is going to change based on an event. So here the event is flipping a coin and the second event is rolling a single die. Okay, so here how can we calculate the probability here? So I want to understand the probability of getting 1 as output. When I just roll a single die, what is the probability of getting 1 as output? So number of interested events is 1 divided by total number of events is 6. So 1 by 6 is the probability. Now what else? So this is fine. Variable is fine because we have different outputs and there is several possible values to occur. That is why it is called as a variable. Now what is random? It is random because there is some chance associated with each possible value. Just like I've told, so there are different possible values present, right? Within these possible values, here, maybe 1 may be occur, 2 may be occur, 3 may be happen, or 4, 5, 6. So it is random. The output may be random. We can't fix or we can't guess that, okay, fine. When I just roll a single die, 3 will be my output. There is no chance of getting only 3. So we have random chance of getting each and every possible value. So that is why this is called as a random variable. So here flipping a coin is a random variable because here there may be the outputs like heads or tails. So it is having several possible values which is called as a variable. And each and every output or the possible value has some chance to get as output which is random. So that is why this event is called as a random variable. Okay, fine. Random variable is fine. Whatever the several possible values is fine. And also probability of each and every output is also fine. Now what else? You always have to remember one more thing, which is, I'll erase these things. So always you have to remember a random variable is always represented using capital letters. So what do you mean by capital letters? For suppose we have a column which is maybe age column. Okay, age is the event over here. And in this age, I have, so maybe the person's age may be 20, he may be 30, he may be 35, he may be 21. So there are different possible values, which means variable. And there is a chance of each and every output to be get. So that is random. So this is called as a random variable. Now, age is a random variable here. Now, how to represent age? With the help of capital letter, I'll call it as X. So age is a random variable here because of these features that we have talked before. And then we always said before, right? Random variable is always represented using capital letters. That is, I'm taking it as X. You can take it as A or you can take it as B also. Anything is fine. Now what? Here, the sub-levels or the members present or the events present or the outcomes present, those are represented using small letters, which is I can call it as x1. And then what? I can call it as x2. And the next one, I can call it as x3. So whatever that you want, you can call using small letters. This is how a random variable is going to be represented. So I am taking age as a random variable because the output is varying, which is having several possible values, and each and every possible value is having some chance to get occurred. That is why this is called as a random variable. And coming to the random variable, it is always represented using capital letter. I can take it as capital X or capital A or capital B. Anything is fine. It depends on your requirement or depends on your choosing. So all the members or all the outputs present within that random variable are represented using small letters. So this is what we have in case of random variable. Now what else? What else is there? Anything else is there? Yes. So here, when we are calculating probability of every outcome in a particular event. So as we have taken, I'll take one example. So here we have taken the first one as, sorry. So we have taken the first event as flipping a coin, as it is showing it here. So when we are flipping a coin, what is the output? It may be heads or it may be tails. These are the two outputs that I can get. So what is the probability of heads to get occurred? That is 1/2. The probability of heads to occur is 1/2. And the probability of tails to occur is also 1/2. So when we add all the probabilities of all the outcome of a particular event, it should be always equals to 1. What is it? When we add the probabilities of every outcome of a particular event, it should be always equals to 1. This concept is called as probability distribution. What is this called? This is called as probability distribution. Why we are calling this as probability distribution? What do you mean by probability distribution? So probability distribution is nothing but we are what we can call, if we distribute the probabilities, across multiple outcomes for an event, then it is called as probability distribution. In this case, we are distributing the probability across heads and tails. So the output of these two probabilities will always be equals to 1. And such concept is called as probability distribution. So if we distribute the probabilities across multiple outcomes for an event, it is called as probability distribution. And in probability distribution also, we will have different cases like discrete probability distribution as well as continuous probability distribution. We will talk about that in next example. So what we have discussed up to now in this particular module, so we have seen what is probability, which is a measure which talks about how likely some event is going to happen. And the second one that we have discussed is what is a random variable. So random variable is nothing but a variable which is having several possible outcomes, and there is a chance of every outcome to be occurred in that particular event, which is random. So that is why this is called as random variable. So random variables are always represented using capital letters. You can take any alphabet that you want. And also there is one more thing which is nothing but probability distribution. So when we are having an event going to occur, it is having a lot of outcomes that can be possible. So when we distribute the probabilities across multiple outcomes for an event, such concept is called as probability distribution. And when we add the probabilities of all those events, it will be always equals to 1. So let me delete this and we will see what is the other example present. Okay. The next one that we have is this one, which is talking about the emotions of a person. So a person can't be in a single emotion all the time. He may get varying outcomes like what? He may be fascinating, He may be he is feeling satisfied, he is desired, he is feeling sad, he is feeling joy, he is feeling bored. All of these comes under various possible values. So that is why it is called as a variable. And he each and every outcome or value have the possibility or the chance to occur. That is random. So that is called as, here this example, the emotion is nothing but a random variable. And in here, this flipping a coin is the random variable. So probability is completed, and we have also seen random variable. Next, what is there? So probability distribution is there. Probability distribution is nothing but distributing the probability across multiple outcomes for a particular event. Distributing the probability across multiple outcomes for an event is called as probability distribution. What is there in this? So here, he is taking an example. What is that example talking about? What is that example talking about? So here, he is talking about the example. What is the daily sales of Apple iPads at a store? So daily sales of Apple iPads at a store. He is wanting to talk about the daily sales. Now, how to describe this in the form of probability distribution? So here, see, in this example, he is just noting down the sales of 100 days. Imagine he is noting down the sales of 100 days, and out of 100 days, for suppose on day 1, how many iPads are getting sold? How many iPads are getting sold? He is noting all those down for 100 days. Okay, this is the concept over here. Now let's see what is there in the example. So this example is talking about the sales of 100 days of Apple iPads at a particular store X. Here X is nothing but capital letter because the Apple iPad sales is varying and random. That is why this is described with the help of capital letter, which is nothing but a random variable. Now what is there in the example? Let us see in the example here. So here, see, the days are totally of 100. For 100 days, it is calculating the sales of iPads on each and every day. So it is calculating the sales of iPads on each and every day. Now what is happening? So we have to understand, first of all, what are the unique values? What are the unique values present in sales of iPad column or random variable column? So what do you mean by unique values? So here you can see 0 is happening again on first day and also on 6th day, which means on first day, the sales of iPads are 0. Nothing is sold. And also on 6th day, nothing was sold. And second day, 4 iPads were sold. All of these are indicated in the column, which is sales of iPad. So within that, we have to understand what are the unique values present. So let us take the unique values as, so there is 0 present, there is 1 present, there is 2 present, 3 present, and 4 present. You can see 0, 1, 2, 3, 4. That is the maximum value. Now what is this? So why this we are calling it as a random variable? The output may be 0, maybe 1, maybe 2, maybe 3, or maybe 4. So the outputs are varying. And also anything may occur. We don't know what is exactly going to happen. That is random. So that is why this sales of iPad is called as a random variable, which is indicated with the help of capital X. Now, within this, I want to know what is the probability of 0 to occur in this particular event. So I want to understand this thing. So as we told before, when the probability is distributed across multiple outcomes of an event, that is called as probability distribution. Here it is distributed across 0, 1, 2, 3, and 4. Now I want to know the probability of 0 to occur in this particular event. At the same time, I want to know the probability of 1, probability of 2, probability of 3, as well as 4. Now, if you see here in the example provided, it is showing, see here, X is the random variable here, and it is having the unique values 0, 1, 2, 3, and 4, as we have written here. And what is the probability? So, Here, how it is taking it as 0.40, 0.25, 0.20, and so on. So it is taking like out of 100 days, on totally of 40 days, the sales are 0. So why this is taking as 0.40? Here, out of 100 days in this particular example or the table given, 40 days, out of 100 days, the 40 days sales are 0, which means how can we calculate the probability? The number of interested events, which is nothing but 40, divided by total number of events, 100, which is equals to 0.4. That is how the calculation is made and it is provided in this table. Okay. So, and also imagine the sales one number of iPads sold, which is 1, is happening for 25 days. The probability is nothing but number of interested events divided by total number of events, which is equals to 0.25. So when you add all these things, it will be equal to 100. Like 40 plus 25 plus 20 plus 5 plus 10. If you calculate this one, which is 40, 65, 85, 90, and 100. So out of 100 days, this is the probability of the like a 0, 1, 2, 3, and 4. So when the probability is distributed across multiple outcomes of an event, such type of distribution is called as probability distribution. And also, there are different types of probability distributions here. And if the distribution of probability, if the distribution of probability of multiple outcomes is represented in the form of a table, such type of table is called as probability distribution table. Okay, when the distribution of the probability for the multiple outcomes is represented in the form of a table, that is called as probability distribution table. So probability distribution can be shown with the help of either table or it can be shown with the help of graphs as well. So what do you mean by graphs? How can you create graphs when you want to talk about the probability distribution? So how can you show this graphs? So here when you see what is present in this particular chart provided, you can see here. So let me go back. So here see, this is called as graph. Let me erase everything because that is clumsy over there. So the probability distribution is either in the form of a table or in the form of a graph. So here in the graph, if you see, it is provided here 0, 1, 2, 3, 4. That is nothing but the unique values present in this particular random variable column. And on y-axis, it is showing the probabilities. So 0, 4, 0 is this one, which is the probability of this. Let me just take some other color. So here, if you observe, these are the unique values and these are the probabilities. And if you see this bar, 40 is nothing but 0 sales and 25 maybe it is 1 sales and 20 is nothing but 2 sales and then 3 sales is 5 and 4 sales is 10. This is how we are representing the probability either in the form of a table or in the form of a chart or a graph. This is called as probability distribution table. So probability is nothing but the measure which talks about how likely some event is going to happen. It may be having multiple outputs which may be varying, and also there is a chance of every outcome to come which is random. So probability outcomes may be called as random variables. And also when the probability is distributed across multiple events or outcomes of an event, that distribution is called as probability distribution. And also when the random variable, so here I'll write one more point. So when the random variable is discrete, so we have talked about continuous and discrete before, right? When the random variable is discrete, the probability distribution is called as discrete probability distribution. It is called as discrete probability distribution. Okay. If the random variable is not discrete, then when the random variable is continuous, it is called as continuous probability distribution. It is called as continuous probability distribution. So what do you mean by random variable is discrete, random variable is continuous? So here, if we take the example provided here, so the sales of iPad, these are, what is this, discrete or continuous? This is discrete data. Why this is discrete? This is discrete. Why this is a discrete column? Why? Because if we represent these outcomes or levels present in this in decimal format, like I have sold 3.4 iPads on 5th day. So when I take this in decimal format, this does not make any sense. So sales of iPad random variable is a discrete column or a discrete data type. So such type of probability distribution is called as discrete probability distribution. Now what is continuous? When we have the random variable, for suppose take it as income. When we have income over here, instead of sales, we have income. So when we have income, we can represent, maybe I got 4,500.00. I can write whatever I want, right? So 4,500.00. So I can represent in decimal format. It makes some sense. So this is called as continuous data. So continuous data, if the random variable is present, that probability distribution is called as continuous probability distribution. So the probability distribution that we have may be discrete or it may be continuous. So based on the random variable, we will say whether it is discrete probability distribution or continuous. Let's see what is present in our mind maps regarding the probability. Just a second. So I'll go back to the mind map, which is there. Here, when we go over here, we are talking about explanatory data analysis. Before going into that topic, we are talking about probability here on the left-hand side. So probability. So probability is nothing but number of interested events divided by total number of events. And then what? Probability distribution is nothing but it is based on, based on when we are creating this one. On x-axis, we will have random variable. On y-axis, we will have probability, just like we have seen before. So on x-axis, we are having 0, 1, 2, 3, which is nothing but sales, which is random variable. So on x-axis, we will have random variable. On y-axis, we will have probabilities like 0.40 or 0.5, 0.10, 0.20, 0.40. All these things we will have on y-axis, which is nothing but probability. So probability distribution on x-axis will have random variable. On y-axis, we will have probability. Now, when the random variable is continuous, this is called as continuous probability distribution. When the random variable is discrete, this is called as discrete probability distribution. So here you have different methods present. You can go through everything, properties and all. And discrete also, you will have different methods or distributions present. You can go through everything. So this is the basics of probability distribution. Now let's talk about the next one, which is inferential statistics. So we will go back to our slides over there. Let me clear the drawings over here. So let us go back to the next one, which is inferential statistics. So what do you mean by inferential statistics? What do you mean by inferential statistics here? So inferential statistics, okay, fine. For suppose there is a huge population present. Oh, so here we will take an example. So here the example may be, so that is not properly written over here. Okay, let me take the example. So here there is an example like, there is a person who wants to know, whether the iPhone users are happy about the battery life or not. So there is a person, maybe he is the management or he belongs to the CEO of that particular company, whatever the case may be. So he wants to know whether the iPhone users are happy about the battery life or not. So what is the population here? So here, the total number of users who are using the iPhone, it may be around 100 million. So this comes under population. So how many users using that particular mobile, in our case, iPhone, that is comes under population. Okay. After population, what is there? After population, what is there? So when I want to just contact 100 million people to know whether they are happy about the battery life of their phone or not, it is not the possible way to do. That is not also the feasible thing to do for anywhere. Like whatever the case may be, whether this one or any example, working on huge population is not the suggestible thing. So now what we will do, for that, we have an optional thing which is sampling frame. So the second one coming here is sampling frame. That is not written over there, I guess. So what is sampling frame? Sampling frame, this is an optional one which is mostly business driven. So this is an optional one which is mostly business driven. And what can we say about this sampling frame? So instead of knowing the feedback of 100 million people using the iPhones, we can draw the insights, or we can just get information like what? Based on the sampling frame, I understood like most of the iPhone users belongs to US and UK. So let us imagine out of 100 million population using the iPhones, 80% of them belongs to US and UK. So this is what I have got based on sampling frame that I did. So sampling frame is an optional thing. It depends upon your opinion, what you want to do and not. So here I have did my sampling frame within which I got the concept like, so out of the total population who are using the mobile, which is iPhone, 80% belongs to US and UK. Now, what is the use of that particular thing or sampling frame that I got? So based on this, I'll apply methods like what? Here I'm applying a method which is simple random sampling. So simple random sampling, this we can call it as a blindfolded technique. This we can call it as a blindfolded technique. Why this is called as a blindfolded technique? So here what we are doing, I have got some information like 80% of the population are belonging to US and UK. Now with that information, what else I can do? I can just perform some techniques like this blindfolded technique in which I don't have any bias. Here I don't have any bias, which means what? I am not preferring whatever the people that I want. Here I am just closing my eyes and I'm picking some random people out of the 80% population present. Out of the 80% population present in the US and UK, I'm randomly picking few people. I'm not picking only I want female users feedback. I want only male users feedback. I'm not doing such things. I'm not showing any bias. So the only one technique which will not show any bias, which will randomly pick the output from random population is simple random sampling method. So when I randomly choose some people for getting the feedback, what else I can do? I will just make that into sample, which means I have to understand out of 80%, I'm randomly picking few people, how much percentage I want to pick out of 80%. So I can't go to the 80% people and know the feedback rate. So what I do is I'll prepare the sample. I have shown you this sample operator before, right? I'll show it again in this RapidMiner Studio product again. So sample. So what does the sample means? So out of 80% present in US and UK, I'm going to select 20% of the population, which means I'm randomly picking 20% of those people present in US and UK. So why am I picking only 20%? Because I can't just get an understanding of 80% of people's feedback and draw the insights, right? In order to draw the insights, it is better to work on sample data instead of huge amount of data. So based on the feedback I got from those 20% people, I got inferences like, or insights, anything is fine. Inferences like most of the iPhone users are satisfied with their battery life. This is what I got the information from this particular 20%. So population here is the number of users using the iPhone. And the second thing that is having the sampling frame, which is optional. And this is also business driven. Here using this, I got the information like most of the users are belonging to the US and UK who are using that particular iPhone. which is mostly 80%. And then I'm using some technique, which is simple random sampling. This is a blindfolded technique, which is not showing any bias towards anybody. It is randomly picking out of 80% few of the population and getting the feedback. So how many are I choosing? That depends on the sample. So here out of 80% present in US and UK, I'm choosing 20% of people using simple random sampling. Simple random sampling, this is okay. I've written this spelling wrong. So based on that feedback of those people, I have drawn some inferences like most of the iPhone users are satisfied with their battery life. So when we are, so what can we say further? When we are drawing some inferences, from a sample of a population, when we are drawing the inferences from a sample of a population, such type of statistics is called as inferential statistics. Such type of statistics is called as inferential statistics. So this is nothing but the concept of inferential statistics. So when we are drawing some inferences from a sample of a population, then such a concept is called as inferential statistics. So here I have taken an example to make you understand easily. So iPhone users is the population. Out of those, I have understood 80% belongs to a single region. And out of those 80%, I'm using some technique to randomly pick the people. And in that 80%, I am choosing the sample as 20% and drawing the inferences like what most of the people I have selected from my sample of the population are satisfied with the battery life. These are the inferences that I got, which is nothing but inferential statistics. I have already shown you before how to use this. I've already shown you the operator sample. So let us take the operator sample here. Let me erase these drawings. Okay, I'll go back to my RapidMiner studio. Here I've shown you the sample. So let me show you the sample in huge data set. Okay, so we have the data set, which is sample superstore rate. I'm going to use the sample superstore data set, which is an Excel file using the operator read. So here you have to understand the concept. I want to read the data which is belonging to an Excel file. So I should use the operator read Excel. Before I have used read CSV because my data set is the CSV file. But right now, my file is an Excel file. So read Excel, double click on this one. You will get to the option where you have to choose your file. I will choose sample superstore. I'm choosing sample superstore. I'm clicking on next over here. So this is loading the details of particular sheets that I want. So in our sample superstore, we have three different sheets: orders, people, and returns. Out of these three sheets, I'm going to use orders. I'm not changing anything. Just the orders is fine. Orders, and next, I'm not formatting any columns. I'm not changing anything. I'm retaining it as it is. So I'm simply clicking on finish. When I click on finish, how I get the output? I want to connect the output to the response. And I have to execute this one. Now I will get the output. So totally there are, in my data set of sample superstore Excel file, I have 9997 records and 21 columns. Now I want to get the understanding of what out of these columns, how many belongs to a particular region or a particular country. So I want to draw some inferences. So I want to work on few records, not on 9997 records. So how to just create a sample in this particular RapidMiner studio? You have to use the operator here, which is sample. So I'm going to use the sample. And also, if you don't want to work on all the columns, I don't want everything for my analysis process, I want to remove some. Then what I told you, you can use the operator, which is select attributes. So select attributes, take it directly on the line. It will make the connection. So see here, this is easy to use. Now, out of all the columns present, I want to exclude. What are the attributes I want to exclude? A subset, not a single thing. So what are these? I will select here. So I want to exclude customer ID. I don't want it. Double click on it. And I don't want order ID. I don't want postal code. I don't want product ID. I don't want maybe ship date, order date. I don't want city. I don't want country. Everything belongs to a single country. I don't want it. Customer name is also no, I don't want. Discount, profit, quantity, region. Okay, these columns are enough for me. I'm removing these columns. So exclude, I've taken exclude. So I'm selecting whatever that I want to exclude. If you take include, just mention whatever that you want to include. So click on apply. So I've selected my attributes. I'll see whether I got the attributes correctly or not. So see, whatever that I have not selected, those are present in my process. So out of multiple columns I've removed, I got now 12 columns to work with. Now I want to create sample out of these 9997 records. So sample, take it into here. And out of those records, 9997, I want to work with only 600 records. So write in the parameter of the sample 600. Now execute this one. We did not make the connection. If the connection is not proper, it won't give us the output. So I'll connect it again. So now it is giving me 600 records. Now I can perform any action I want on these records and get the insights. So this is how we can use the operator sample in our RapidMiner Studio. That is about inferential statistics sample present here. So it is 10:30. Let's take a 10-minute break and we will get back and we'll start discussing about the business movements. I'll be on mute. I'll get back after 10 minutes. Okay, everybody, let's continue with the session. Okay, so we have seen up to inferential statistics, right? Now we'll talk about what is there further. Okay, there comes the first business movement, which is measures of central tendency. So what is measures of central tendency? How can we say or how can we talk about the measures of central tendency? And why these are called as first movement business decisions? So here, maybe first of all, let me take an example and show it to you. So here, I will take an example like what? There is a CEO present for a particular bank. This is just an example, okay? So there is a CEO for a particular bank and he's just having a lot of different branches in different locations. Like what? He had branches like in Malaysia and Singapore and whatever that you take, okay? Just an example. So in lot of different branches, that CEO particular CEO of that bank, he wants to understand like what, there may be few questions that arises, right? So on an average, how much loan they are just distributing or giving for automotives, or how much loan was allotted towards education loan, or on an average, how much salaries are they are paying for the employees across multiple locations. So these are the questions that may arise in their particular minds. So these are the initial set of questions that arises for anybody. That is why these are called as first business movement. So initial set of questions. So that is why we can call it as first movement business decision. First moment business decision. And what else? What else can we talk about this one? So these are the initial set of questions. That is why these are called as first moment business decisions. Now, within that, we have multiple measures. Like what? So we have mean, we have median, and we have the third one, which is mode. So what is mean, what is median, what is mode, and what are these formulas present? So how can we say about mean, median, and mode, which are the measures present in first moment business decision? So here, if you understand, when you are calculating mean or median or mode for a population, that is indicated with the help of mu. So we have talked about population and sample before. If we are calculating the population, that is indicated with capital N. Capital N is nothing but population and small n is nothing but sample. Capital N is population and small n is nothing but sample. Now, if we want to calculate the mean is nothing but average. Mean is nothing but the average. Average, you know how to calculate. We have worked on it from Excel onwards, right? So when we have multiple numbers present, we will add all those numbers and divide it by total number of numbers, which is nothing but average. So here, mu is nothing but, this is a Greek notation. When we are calculating mean, median, mode for a particular population, it is indicated with capital N. And if we are calculating it for sample, which is sample of a population, it is indicated with the help of small n. Small n. Now, how can we talk about mean, median, mode in more, which makes much sense? So in this, I can't talk about mean, median, mode, which will not be understood by you easily. So let's take an Excel sheet and work in the Excel sheet. So let us go back to the Excel sheet. So let me open my Excel. For suppose, we will imagine a data set having few numbers and we will calculate mean, median and mode. What is mean, what is median, what is mode we'll discuss and we will have an understanding. So let me zoom in a bit. So here, imagine there is a data set present, which is data set 1. Okay. In this data set 1, we have numbers like 1, 2, 3, 4, and 5. Just the random numbers, okay? Now, as we talked about, random variable is indicated with the help of capital letter and all the events that are going to happen or all the outcomes that are going to happen, those are indicated with small letters. This is X1, this is X2, this is X3, this is X4, and this is X5. Okay, up to here, this is fine. Now, for this particular data set, how can we calculate mean? Mean is nothing but average, as we told before. How can we calculate mean for this particular data set 1? So, mean, what is the formula that we have written before? Mean is nothing but, so how can we write the formula here? For mean, there is a formula that is sigma I is equal to sigma, okay. Sigma I is equals to 1 to capital N. If it is for population, we will take it as capital N. If it is sample, we will take it as small n. So, sigma I is equals to 1 to n of x of I, which means I is changing randomly x1, x2, x3, x4, and x5. Divided by what? Divided by total population, which is n. So, how can we just calculate the mean from this one? So, here, when I is equals to 1, it will come as x1. And there is a summation present, so plus. And if I is equals to 2, x is equals to 2. Plus what? I is equals to 3, x is equals to 3. So x3 plus, which is summation, x4 plus again x5. Up to how many numbers you will write? How many total population present in your data set? Up to that it will work. In our data set, what is the number of population present? It is 5. So I will take up to 5. x1 plus x2 plus x3 plus x4 plus x5 divided by 5. Why divided by 5? Why? Because the population is 5. So how can we calculate this one? Which is equals to 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So this is not taking properly because we did not mention the brackets. I'll write the brackets over here. So that is 3. 15 divided by 5, that is equals to 3. This is how, based on the formula, we will calculate the mean or average of a particular data set. So for this data set using Excel, how can we calculate the mean? Using the function average. So I can simply use average, select the numbers, click on enter. So this is 3. Fine, this is fine. Now what is there? For suppose, imagine you have another data set. There is another data set, which is data set 2. Within this data set, I have extreme values. Like I have 1 and I have 200, 300, 400, and I have 7,000 or 70,000. So when you just look at this data, this is extremely high. When we compare to the other range of values, this is extremely high. And this one is extremely low. This one is extremely low. So you already know the extreme values. If it is high or low, those are considered as outliers. So whenever your data or a column is having certain values which are not in the range of other values which are extremely small or extremely large, such values are called as outliers. So when you have outliers in your data, what will be your mean value? So how can I calculate the mean? Using average function. So average, I'll click on enter. So see, based on the values, the mean is extremely large. So we can also take an example with the data which is same to the data set 1. 1, 2, 3, 4. I have here an outlier which is 600. This is also extremely high rate. When I calculate the average of this data, this is 122. So this data set and this data set are almost similar, but exception is that in this data set 1, I have 5 numbers from 1 to 5. But in this data set, I have 1 to 4, that is same. But instead of 5, I got an extreme high value, which is an outlier, that is 600. So because of the presence of outliers, my mean got influenced and the value got changed completely. So what can you understand from this point? Mean gets influenced by outliers. Mean gets influenced by outliers. And what is the second thing present? Second, first movement business decision present. You have the second one, that is median. I'll just clear this drawing. So the second one that we have is median. So how to calculate median? So what I do is I'll take another data set here. This is data set 3. This is having the numbers, imagine 1, 2, 3, 4, and 600. I'm writing the same. There is a data set for which I have to calculate mean and median. For this, the mean is calculated using average. So average of this number, which is 122, this is same. and I want to calculate the second one, which is median, I have to use the function which is median. So median of these numbers is equal to how much? It is 3. Even the data set is having the outliers or not having the outliers, the median is not getting influenced. Let us check it out in the normal data. So I'll have here the same data, and I will just write here using the same function average. We can drag and drop, or we can just use the handle also. I'm just writing because it will be easy for you to understand. So median of this one, 3. So even the data which is having the outlier or the data which is not having the outlier, the median is same. So what can you understand from this particular data set? Median does not get influenced by outliers. This is just the easy way of understanding these points. Mean gets influenced by outliers and median does not get influenced by outliers. When you have data like 3, 4, 600, 1 and 2. Now what will be the mean and median? So mean is nothing but average, that will be same. And how to calculate median? So before we are calculating the median, you have to sort your data. After sorting your data, whatever the value that is present in the middle of your data set, that will be your median value. So median is nothing but the middlemost value of your data or a column. So in this, you can't say the middle value is 600. So my median is 600. You can't say that because this is not in properly sorted manner. So I have to check it out whether the data is sorted or not, then I have to calculate the median. So if we are using the function, that is fine. But in the normal sense, what it does is in the backend, it will first sort the data 3, 4, 600, and it will check what is the middlemost value in that column. So out of all the numbers, 3 is the middlemost number. So 3 is your median. That is how we will calculate the median. So mean is nothing but the average. Median is nothing but the middlemost value in the data set or a column. Mean gets influenced by the outliers, whereas median will not get influenced by outliers. For suppose this is odd number of values present in a column. For suppose if you have even number of columns, 1, 2, 3, 4, 5, and 6. Now for this, how can I calculate median? How can I calculate median? I told median is nothing but the middlemost value. But in my data set, I have 6 values. So how can I get the middle one? So out of 6 values, the 2 values in the center is treated as the middlemost value because this is an even number of values present in the data set. Now, how will it calculate the median is by taking the average of the middle 2 values, which is 3 plus 4 divided by 2. We have to give the arrows first. Without the arrows, it won't take the value properly. So 3.5. If I use the median function also, it will give me the output 3.5. See, that is how we will calculate the median when we have even number of values present in our data set. So median is the middlemost value and mean is the average of the value. Then what is the last one that we have? The last one that we have is mode. What is mode? So mode is nothing but whatever the value that is occurring mostly in your data set or a column, that is nothing but a mode. So here we will prefer mode when we have categorical data. When we have categorical data, we will mostly prefer mode. Just like for suppose there is a column. There is a column which talks about whether the sales is high or moderate or low. So there is a column. So here the values are high sales, moderate sales, low sales, again high, again low, again high, again low, moderate, high. So these are the values present. Now I have to calculate mean, median, and mode for this data set. How can I calculate mean, median, mode? So for categorical data, we can't calculate mean and median. We can't calculate mean and median. So we can simply write it as NA and NA. Mean, median is fine. What about the mode? So mode is mostly preferred for categorical data. So here, out of all the values present here, how much or what is the most occurring value? So high, it is occurring for 1, 2, 3, 4 times. moderate is appeared for 2 times, and low is appeared for 3 times. So out of all the values, high is the most occurred one. So the mode of this particular column is high. So mode is basically the one which is appearing most of the times, and mode is mostly preferred when we have categorical data. And also, if we have one mode in our data, that is called as unimodal, which is uni means one. If we have 2 modes, that is called as bimodal. And if we have greater than 2 modes, then it is called as multimodal. So this is how we will talk about the modes. Like what, for suppose, imagine here you have again low. Okay, now the high and low both are occurring for 4 times. Now in our data set, we have 2 modes. First is high and second one is low. This is how we will call our data set as bimodal, because our data set or this column is having 2 modes appearing for more times. So we are having 2 modes. So 2 modes will indicate the presence of clusters or segments that we will talk about when we are talking about the predictive modeling and all. So for now, these are the basic things to know about the first moment business decisions, which is measure of central tendency. It usually consists of mean, median, and mode. Mean is nothing but the average. Median is nothing but the one that occurs which is the center one, and mode is nothing but the one that is occurring multiple times. So mean is getting influenced by the outliers, whereas median will not get influenced by the outliers. And also when you have a single mode, it is called as unimodal. When you are having 2 modes, it is called as bimodal. When you are having greater than 2 modes, it is called as multimodal. And when you are having 2 modes or greater than 2 modes in your data set, it will indicate the presence of segments or clusters in your data. So mean, median, and mode, 3 different business movements or the first moment business decisions are there, out of which when we have categorical data, we will prefer mode. For count data also, we will prefer mostly mode, but also we will go for mean and median. For numerical data, we will calculate using mean and median. This is how we will talk about the measures of central tendency, which we have in this particular slide. So here, if you observe, this is the measures of central tendency present first moment business decision. If we are calculating for the population, it is called as population parameters, which is indicated with the help of mu Greek notation. And here this capital N represents population. And when we are calculating for the sample, it is indicated with the help of small n, which is nothing but sample. So median is the middlemost value and mode is the most repeated value of a data set. Okay, so this is about measures of central tendency. Now let's see what is present in our mind map. So we are done with the probability distribution, as well as inferential statistics. Now we are moving on to the exploratory data analysis part. So in this exploratory data analysis, you have different business movements. We are talking about the first business movement, which is measures of central tendency. So here, if you see, there is mean, there is median, there is mode. Mean is also called as average, and mean gets influenced by outliers. And median is the middlemost value of the data set, and it does not get influenced by the outliers. And mode, the value which repeat maximum times, is called as mode. If it is having a single mode, it is called as unimodal. If it is having 2 modes, it is called as bimodal. And if the modes are greater than 2, then it is multimodal. More mode indicate presence of clusters. This is about the first moment business decision, which is measures of central tendency. Now let's see how we can calculate the measures of central tendency, which is mean median, in this particular concept, which is RapidMiner Studio. So let us go back to our RapidMiner Studio. So I will just delete this one, what I have taken before. So select everything and delete, or individually you can select and delete. Anything is fine. I'm selecting everything in one go. So you can see the orange color getting highlighted, which is indicating they are selected. Click on delete. Now everything is gone. Now I want to show you how to just use or how to get the understanding of mean, median of a particular column. Okay, so first of all, we have to import the data. We can use any data set that we want. I'm going to show you here, maybe ethnic diversity that is present in the practice, I guess. If you don't have in your practice repository or whatever the repository that you have, you can just use read CSV operator and you can just import the data. Read CSV operator, I'm using it here. Double click on this operator here and select your file. Anything is fine. Education or ethnic diversity, anything is fine. I'm selecting here ethnic diversity. Click on next. I'm not changing anything. I'm not formatting anything. Click on finish. Once you do this, the data got imported. And now you can just connect this port to the response port and execute this process and get the output. And also, you have to understand one thing, which is in statistics, you can see the most occurred ones. So here, when you see here, this one, which is age, out of all the different things present, 54 is the maximum, 23 is the minimum. But when we are calculating for this categorical columns, nominal is nothing but categorical. Here under the race, white is occurring most. And here citizen descending, you have US citizen. And employment status is mostly active. That most is nothing but mode. So here, when I open our ethnic diversity, so let me open my ethnic diversity here. Okay, sorry. Let me open my ethnic diversity. Yeah. So in my ethnic diversity here, we have different columns present. So out of which we can understand how many are present, like totally how many columns are present, we can easily understand by here. This, you can see under the data, there are totally 13 columns and 310 records. So out of which, if we want to find out the statistics, the normal statistics like data types, missing values, and the minimum maximum for numerical columns, and the least occurred ones and the most occurred ones for categorical columns under the statistics part. Now, I want to calculate the mean and median. Mode is fine for categorical columns. Now I want to find mean and median using an operator. Which operator I have to use? I have to use here the operator which is extract aggregates. Everybody, I have to use here the operator which is extract aggregate, which is giving me whatever the output that I want. Maybe it is standard deviation, or it is kurtosis, or it is mean, which is average, or it is total or sum, whatever I want, this particular operator will give me. So I have loaded or imported my data and I'm using this operator extract aggregates. Now I have to connect the output of the first operator as input to the second operator. So read CSV output will be the input for extract aggregates and we have to execute this one. Now I want to calculate only mean and median. So when I go to the parameters of extract aggregates here, I have a lot of things checked in. So what I do is, I'll go to here and I'll check only mean and I'll check only mean and median. So I'm just unchecking everything else present. So I'm calculating mean and median. Now I'll execute this process. Once I execute this process, you can understand here for all the numerical columns that I have, what is the mean and what is the median. For all the other columns, if you can't see this is because remaining everything are categorical columns. For categorical columns, we can't calculate mean and median that we have discussed before, which is shown over here. Okay, if you understand like what employee ID is also does not make sense when we calculate median and mean, we can remove this column for particular aggregation as well. How to do this? So here under the parameters, you can choose here what attributes that you want to do the aggregation for. You can choose a subset. So what can I choose over here? Select the attributes. Out of the 4 columns, I don't want employee ID. Age is fine. If you don't want age also, you can remove it. I just want salaries. Salaries will make sense. So I click on salaries over here and I want to calculate mean and median for salaries and I will execute this process. So for salaries, the mean is 36,670 and the median is 34,554. So the most of the salaries or what is that? The average of salaries for every employee in this particular ethnic diversity data set is around 36,670. That is how we can get the understanding of mean, median, and mode in RapidMiner Studio in just dragging and dropping a single operator and executing the process. You will simply get all these things. So you don't need to just write any code like in Python. We will write for mean, what to do, for median, what to do, for mode, what to do. We will write everything in SQL and Python manually. So here in this RapidMiner Studio, there is no need to do that. You can drag and drop the operators that you want, make the connection and execute the process and get the output in results view. This is how you can calculate all these things. Okay, this is how you can calculate all these things. Now let's see what can we do further. Okay, measures of central tendency, which is first movement business decision is fine. Now let's see what can we do further. So let us go back to our slides present over here. Now let's see what is there in the next slide. Okay, measures of central tendency is fine. Now the second one, the second movement business decision that we have is measures of dispersion. What is this measures of dispersion? So we are telling that as this is the second movement business decision. This is second movement business decision. And with the help of this, we can call it as this. These are the second set of questions like for the any management can arise. And dispersion is nothing but, how can we call dispersion as? Dispersion is nothing but fluctuation, or we can also call it as variation. Anything is fine. So how can we calculate this one? Maybe I can call this as, see here, as we have taken an example before, there is a CEO of a bank. There is a CEO of a bank who is having different branches. Right. So he is having different branches at different locations. Now what he wants to understand? What he wants to understand? He wants to understand the second set of question. What is it? So for suppose, he want to know, for suppose this particular first chart and second chart, there are two charts, right? This is belonging to one particular region, Malaysia, imagine. And this is belonging to second one, which is Singapore. This is just an example. So here, but that particular person wants to know how much is the fluctuation happening between the past six months of sales from the average. What is it? He wants to understand what is the fluctuations or variations happening from the past 6 months sales in the respective locations from the average. So what is the fluctuation happening? We want to understand that concept with the help of the second movement business decision, which is measures of dispersion. So in measures of dispersion, we have a few things like standard deviation, variance. We will talk about it later. Before going into that, we will see this example over here. Okay. So in this example, here, as I talked about, there is 6 month sales. We are calculating the fluctuation happening from the average. Imagine this is the first month. This is the second month. This is the third month. This is the fourth month sale. This is the fifth month. And this is the 6th month. So now what? Okay. Here, imagine this is X bar, which is nothing but average. This is the average. So from the average to the 6 month sales of the previous data, how much fluctuation is happening? This can be talked about with the help of this one. So here we can call it as from the average, this much is the variation happening to the sales data. So this is the fluctuation. This is the fluctuation. So it will show here, see. So this is the fluctuation. This is the fluctuation. So this is how much the fluctuation is happening. and all the variations are present in a particular range, which is shown like this. So see, this is the upper limit, maybe this is the limit. So within this particular range, the variation is happening in particular branch, which is Malaysia, from the average sales data. This is the fluctuation happening. Okay, fine. Malaysia is fine. Now, what about Singapore? So in Singapore also, we will just calculate the fluctuations happening from the past 6 months data sales from the average. This is the average here also. First month, second month, third month, fourth month, fifth month, and sixth month. How can we calculate the fluctuation? This is the fluctuation happening. This is the fluctuation happening. This is the fluctuation happening from the mean. This is also the fluctuation. This is another one, and this is the last one. So it will just combine all these things and it will give you the range again. How it will give you the range? So see, this is the variation happening from the average value to that particular 6 month sales. And here it is showing the pattern. How is it going? And this is the range. Now what? This is the range of variation happening in Singapore branch. Now there is a question like, I want to predict or I want to estimate what may be the future sales value of the next month. What is the future sales value of the next month I want to predict? So is the prediction easy for you in Malaysia data or in Singapore data? You have to understand. So how can we say whether it is easy in Malaysia or in Singapore? It will just you will understand that concept based on this fluctuation happening. So if the fluctuation is less, it is easy for you to get the understanding more. So if the fluctuation is more or the variations are more, it is it takes some time for you to get some insights from that data. And to make the prediction, you have to understand the pattern. So whenever you are having more variations or fluctuations in your data, it will take more time for you to get those insights. This is a simple concept of dispersion, which is nothing but second moment business decision. The second moment business decision is called as measures of dispersion. Dispersion is nothing but the fluctuations or variations happening. Here we have taken the same example just like before, and there is two individual branches or locations present. Out of these two, where can we calculate or predict the future value easily? That is our concept of measures of dispersion. Now, what are the different measures present under the dispersion? So here we have the second moment business decision, in which we have first one is variance, and second one we have is standard deviation, and the third one we have is range. Okay, so what is variance, what is standard deviation, and what is range? You already know about all these things, but we will have a simple explanation so that we can do that in the practical manner in RapidMiner Studio as well. Okay, so why we are going for the second moment business decisions? Here there is given a simple example. You can take this example. This is somewhat funny, but still it makes sense. So here, imagine there are two people who went for maybe a trip to some island or to some beach place. Now they got a problem there. So they want to move from this place to this place by crossing this particular river present here. They want to cross this one. Now there is a boat present here. So he is the only person present in that particular river. So they want to ask him whether they can drop them from this place to this place. So he is not he is not the person who drops the people. So they asked him the question like, what is the depth of the river? So they asked him the question, what is the question? What is the depth of the river? He told like the depth of the river, maybe it may be 3 feet. So each and every, these two people are maybe 6 feet individually. So the depth of the river is 3 feet. So they may think like, okay, 3 feet, right? We can go and cross the river by themselves. They can think so. But there may be few places where the depth is high. There may be few places where the depth is low. So in such cases, instead of knowing the average of depth, you can understand the concept by knowing the maximum and minimum. So not only the first moment business decisions are enough, you also have few more aggregations present, which is called as second moment business decisions, which considers as measures of dispersion, within which we have variance, standard deviation, and range. So we will go back to our mind map and we will see what is there regarding the second movement business decision there. So I'll go back here. The first movement business decision is done. Now we will see the second movement business decisions. So the second movement business decision is called as measures of dispersion, which consists of variance, standard deviation, and range. And when we go for variance, the disadvantage is that the units get squared. And standard deviation, here the advantage is that we will get back our original inputs because of the square root of variance. So standard deviation formula is square root of variance. And range is nothing but maximum minus minimum. So these three are the measures present in second movement business decision, which is measures of dispersion. Okay, fine. Now what is that? Now what else is that? For suppose there is a thing like what? For suppose there is a thing like we have to find out there are a few people present and I want to find out what is the probability of the persons present who is of maybe 80 kgs weight. I want to know the probability of people who are 80 kgs weight. So the 80 kgs may not be at most like that is not exact value. He may be 80.1, he may be 79.9, whatever that is. There are a lot of different possibilities like what I can be 1 or he can be maybe 79.9999 something or 9 or he can be maybe 80.001. So there may be a lot of possibilities when we have a lot of decimal places. So when we have the total number of events or total number of possibilities as infinity, so when we are having such type of possibilities present, we can't count them, right? We will take this as infinity. When it is infinity, how can we calculate the probability? How can we calculate the probability for that? So we can calculate the probability like what? Probability formula is number of interested events divided by total number of events. Here, if I want to calculate the number of interested events, that is 1. And number of events, they may be infinity. So 1 by infinity, we can take this as 0. So in order to calculate the probability of a particular event, which is having a lot of different outcomes, which may be infinity, the probability for that case is 0. The probability for that case is 0. This you have to remember. We will talk about this in coming session. Okay, now let's see in the RapidMiner Studio, how can we calculate the variance and standard deviation and all? Minimum, maximum, how can we calculate that one? We will go back to our RapidMiner Studio. Now, I'm going to use sample superstore. I will remove everything here. Now I'm going to use sample superstore, which is already present in my local repository. So sample superstore is present. I'll drag and drop it. Now what? Connect the output port to the response port. Execute the process. You will get the output and check how many columns are numerical. Because we will calculate mean, median only for the numerical columns, right? So here, which makes sense. I will just calculate for sales, quantity, discount and profit. Okay, these 4 are fine. So I'll go back to the design view. Now I will use again the operator extract aggregates. I'll take this operator and I'll keep it over here. And I have to make the output of the first operator as the input to the second operator. Now I have to choose here the columns. So I will choose here subset and within which I have to select my columns. I'm selecting sales, profit, quantity, and discount. Okay. These I want to calculate what? I want to calculate the second movement business decisions. Like what? Median. Okay, sorry. Like minimum, maximum, standard deviation. And variance is nothing but what is that? Square of standard deviation. So there is no specific thing which is present for variance. So I'll click on this execute part. So I did not make the connection to the output or the response. That is why I'm not getting the output. Make sure you connect everything and execute them. So this is how you can calculate everything in a single go by connecting the operators together and executing the process. And statistics, you can see again, what is the data type? What is the statistics? most occurred ones, least occurred ones, and the missing values. This is how you can calculate the second moment business decision measures of dispersion in RapidMiner Studio. Now let's go back to our slides over here. Now let's see what is present. Measures of central tendency and measures of dispersion is fine. Now you have expected value. So this is same that we have talked about before. So probability distribution, the mean is known as expected value. The expected value refers to what one would find if they repeated the experiments infinite number of times. As I have taken an example before, right? When we are performing an experiment for multiple number of times, such type of distribution is called as expected value. So mathematically, how can we calculate this one? This is the formula for expected value. And this is the formula for discrete random variable. This is nothing but the expected variable. When can we get this concept? When we are performing the same event for infinite number of times, we can check it out, this expected value. Now, what is that? Next, coming to here, there is a graphical technique which is bar plot. There is a graphical technique which is bar plot. So first of all, let's talk about what is there in the bar plot. So bar plot is basically, bar plot is a univariate plot. What do you mean by univariate plot? Which means we can plot this particular chart using a single variable. Bar chart is a univariate plot or univariate plot or chart, everything is fine because we can plot this chart using a single variable. Now what? Now I'm going to use here, for suppose imagine this is a bar chart regarding education data set. So we have seen education CSV file before, right? Imagine this is the education data set and this is the bar plot of GMAT course or work experience, anything is fine. This is the bar plot of GMAT course or work experience. Now what to do? Here, now imagine on x-axis we have all these GMAT course or work experience present, and here we have the values. Now in this particular bar plot, if you observe, there are multiple lines present. Why you are having multiple lines? Why? Because when you are having multiple records present in your data source, for suppose I have a data set, imagine I'm taking the same thing, which is education. My data set is having 773 records. And for those records, when I plot a bar plot, it will show me 773 lines. Why? Because each and every line is talking about every record. So 770 lines, in order to get the insights from these particular records is very hard to understand. So here, this bar plot, when I look at it, it is very clumsy, or we can also call it as cluttered. It is very cluttered. So from this bar plot, I can't draw much insights. So why we will just plot the charts in order to draw some meaningful insights and use it for further making informed decisions. But in this current bar plot that I have plotted, I can't draw any insights or get some meaningful information. So what is the use of this bar plot? So I can get some information like what? Maybe I can get the information like in this particular bar plot. I'll just delete this drawings. This is making clumsy. When I just observe this bar plot, there are a lot of different records which are about this particular range. So see, everything is about this particular range. So I can call it as most of the students got the GMAT scores above 600. This is what I can understand from this bar plot. Apart from this, I won't get any understanding from this bar plot because of the huge number of records. So what to do? I'll just delete this. I'll go back to our RapidMiner Studio and we will see how to plot a bar chart in our RapidMiner Studio. So we will see how to plot a bar chart in RapidMiner Studio. Let's go back to our RapidMiner Studio. And here we are talking about the GMAT scores and all of those things, right? Let me delete everything here. And I'm going to use here education CSV file. And I want to plot a bar chart for GMAT scores or work experience. Anything is fine. So you don't have this education already connected, I guess. So I will just show you using read CSV operator. So read CSV, I have taken this operator into the process. and double click on the operator, and I will go and select the education CSV file and click on next. I'm not changing anything. I'm not formatting my columns. I will retain it as is and click on finish. Once I do this, I have to execute this one by connecting the output port to the response port. And I want to execute the process and I will get the output like I got totally 773 records and 3 columns. Now, how to create a bar plot for this particular data set? So here you have visualizations present. You can see it here. In the results view, you have visualizations coming here. You have to just select the visualizations. Click on visualizations now. Under the visualizations, you have here again the plot type. Within the drop down of the plot type, you can choose whatever the chart that you want to create. Here now, I want to create a bar chart regarding the GMAT scores, the bar chart of the education data set, which is a CSV file. I want to take the GMAT scores on the x-axis and I want to see how the chart is looking like. The GMAT scores I want to take. Okay, just ignore the writing. Okay, I'll just delete this thing. Fine. Now what I do, I'll go to the drop down over here and I will select the bar chart. Here you can see, you can select either bar column or bar horizontal. But in this, the lines are vertical, so I'll go for vertical. Now see, this is taking serial number. I don't want serial number. I want GMAT scores. I want maybe the work experience. So see, so based on this particular column that you're choosing, this is getting changed. So here, imagine maybe this is data serial number. So these are the serial numbers having multiple records. Like what? Under the data, if you observe, the data serial numbers are unique for every record, which means you have 773 different values present for every record. When you plot a chart having multiple values in a column, you will get the chart like this, which is very clumsy. This is very clumsy. So here, if you just understand this concept, you can just get the idea like what? Maybe the values or the numbers are present in the range of this to this. You can get an understanding like this. Apart from that, you won't understand anything at all from this particular bar chart. You can change here. I will show the customizations present in the chart as well. So here, so I will change this to work experience. Okay, this is the work experience. Now, the value columns. You want to change the value columns, you can change it. Maybe I'll remove this one. So this is not taking anything, so I have to give the column. So maybe I'll take serial number. So see, this is the chart that I'm getting. Maybe I will take the GMAT scores and I'll see how the chart is getting. So based on your customization, your chart looks like. So see, this is exactly what is present in our chart there. So most of the values are above 600. You can see it here. So I've taken the work experience on x-axis and I've grouped together with the help of GMAT. So here you can see work experience and GMAT. Now, if you want to customize, you can customize using here the colors. If I want to colors with the help of GMAT. So see, this is the GMAT 720 in blue color and green color is 640. And I don't want to group it with the help of GMAT. I want to group or color with the help of work experience. So this is not taking properly. So whatever that is possible, it will be showing the color. So color group column has more than 50. So more than 50 is there. So that is why it is not giving me 50 different colors. So this will not give for serial number also because it is also having more than 50 values. So you can go for none or you can go for whatever you want. The colors. Okay. If you want to change the plot style, you can change it. So I will make the color as dot. So everything will be dotted. See? Okay. If you want to increase the line width, you can increase it. Whatever that you want, the customizations, you can do it here. And x-axis, I want to customize my x-axis. So x-axis, the minimum value I have to take it as 0. And the maximum value I want to take it is 350. Based on what you write, you will get the axis. 0 is the minimum, 350 is the maximum, and within which I have the values of all the work experiences plotted along GMAT in the bar column. I will get like this. And if I want to change the y-axis here, the maximum I can see it is 720 and all. So y-axis, I'll go over here and I'll check the minimum to 0 and maximum I'll take it to 1000. So see 0 to 1000 within which we have the values. And then if I want to give the title, I can give the title here. So I want to get the title in the center and I have here this one. So I will change this one. So this is the example set which is already there. So center. So example set, I want to change this to bar plot. I can get the bar plot. If I want to give the font, I want it bold. So see bar plot which is bold. And if you want to get the subtitle, you can get the subtitle. So this bar plot gives the insight like most GMAT scores are around or above 600. This is what you can understand from this particular chart. That comes under the subtitle present here. Now, if you want to get the legend, you know the legend, right? The color, if you want to get it, you can get it. If you don't want, you can remove it. But I want to get it because I want to get the understanding. So the position also you can set it and the tooltip also you can change. So these are the various customizations that you can do in any chart. Not only this bar plot, any chart you can do. And also after doing it, if you want to save it, you have here the 3 lines present here on the right hand side. So you can go there and you can check it out the options present as PDF or PNG or JPEG or SVG. You can export your chart as however you want. I'm not changing it or I'm not saving it. I'm remaining this as it is. I'm not changing anything. So this is how you will create a bar plot in RapidMiner Studio. So in our particular example that it is showing, in this, I'm not getting much insights because of the number of records is huge. So because of that, I'm not gaining much insights from this chart. So in such cases, what you do? In such cases, we will go for some other type of charts like histogram. So we'll talk about histogram after a quick 10-minute break. Just go for 10-minute break and get back. We will talk about histogram and the other business movements present. Okay, so everybody will continue with the session. Let me just make it full screen. Okay, so we have discussed up to bar plot. So in bar plot, I'm not gaining much information in that particular bar plot. So I have an alternative graphical method or representation, which is histogram. So what is this histogram? So histogram is also a univariate plot. What is it? Histogram is also a univariate plot, which means it is also used to create, it can be also created using a single variable. And before going into the histogram deeply, first you have to understand what is there on x-axis of a histogram and what will be present on y-axis of a histogram. So what is there on x-axis and what is there on y-axis? We will see it in the chart. There will be an example provided here. And also, when you are plotting a histogram, it will automatically create bins or buckets, or you can also call it as groups. Anything is fine. So it will automatically create the bins, buckets, and groups according to the data selection. And as I talked about before, you have to understand what will be there on x-axis and what will be there on y-axis. In this case of histogram, it is present like what? Random variable will be on x-axis and frequencies will be present on y-axis. Why there are frequencies present on y-axis? Because this particular histogram is also called as frequency distribution table or frequency distribution chart. So histogram is representing the frequency distribution, which means how many observations are taking a particular range of value. So that is nothing but the frequencies, and random variable is any column which is having whatever the variables, the possible values are present, everything are represented on the x-axis, and the frequencies like the count of appearances can be indicated on y-axis. So this will create the bins or buckets or groups. Let's see what is present in this particular sheet or slide over here. So a histogram represents the frequency distribution, like how many observations will take the value within a certain interval, which is nothing but a range. And then histogram here, there is an example provided. Random variable is on x-axis and on y-axis you have frequency. So on x-axis you have random variable, on y-axis you have frequency. Now, if you see this chart over here, what can you understand from this particular chart? So when I just draw a line for this chart, this is like this, right? The curve is like this. So when you observe the curve of this chart, what can you understand? Whether the distribution of the data is normal, how can you understand? So here, if you look at the left-hand side, there is a small extension or a small tail present. So apart from this small tail, remaining else everything, you can say that the data is normal or the data are normal. So how can we say the data is normal? So normal distribution data is nothing but the distribution is cut exactly at the center where the left and right part are symmetrical. That is how you can tell whether the data distribution is normal or not. But here in this case of random variable showing here, there is a slight curve or the tail or extension on the left hand side, and it is indicating that remaining else everything is normal apart from the small tail. We will see this when we talk about skewness and everything. So for now, understand there are bins like what? So for suppose imagine this is the difference or the range here is 20. And here the range or the difference here is 20. And the difference between these also 20. So out of all the different bins present over here, this is the one which is having highest peak, which is the highest range of values. So now what can you understand? So in between 700 to 720, maximum range of values falls. So when you observe this particular histogram, in this particular histogram, the range of values, the peak is highest for the range which is in between 700 to 720. So from this particular histogram, what can you understand? In this histogram, I can understand like most of the observations fall under the range which is 700 to 720. These are nothing but the bins. So at the bottom, you can see the range of values 20%, which is nothing but bins. This is what the insight that I can get from this particular histogram. Now, what else I can do? Now, what else? So there is one more thing, which is the density plot. Density plot is similar to histogram, but there is a small difference present. What is the difference? So density plot talks about densities or probabilities, but not frequencies. So what is it? Here I can write one more thing, which is histogram is called frequency distribution, whereas density plot is called as probability distribution. This is called as density. Density plot is called as probability distribution. Why? Because when you observe the axis of density plot and histogram, in the histogram, on y-axis or x-axis, first we'll talk about x-axis. On x-axis here, you will have a random variable in histogram as well as a random variable in density plot. But when you observe the y-axis of both the charts, here you will have frequency. Because of this is called as frequency distribution. In density plot, you will have densities or probabilities. That is why this is called as probability distribution. So that is the only difference between histogram and density plot. Apart from this, everything else is same. You can see the chart. Both of these are same. The chart is same. There is a small tail present. This is also same. Small tail present on the left-hand side, and remaining everything else is normal. This is what there is another univariate plot, which is called as histogram. So why we are talking about the plots? There are 4 business moments or 4 moment of business decisions present. We have discussed only 2, measures of central tendency and measures of dispersion. So what about the remaining ones? There is another one, which is skewness and kurtosis also, right? Why we are not talking about that and we got into the graphical representations first? Why? Because skewness will talk about the symmetry of the distribution, which is nothing but is plotted or can be understood with the help of histogram. That is why first we are discussing about the histogram. Then we'll move on to the next topic, which is third moment business decisions. So here you can observe the next one coming is third moment business decisions. You can call it as these are the third set of questions any management will come for. That is why this is called as third moment business decisions. Before going deep into the topic, we will understand one thing, which is, so first of all, we have discussed the first moment business decision, and then we have second moment business decision, and then comes the third moment business decision. Okay, these are the 3 things that we are discussing. So coming to the first moment. So first moment, you have mean, median, and mode. When we are calculating, how can we calculate? It is right, like we can write it as capital E of X. This is the formula to calculate. Now, for coming to the second moment, so we can calculate it as E of X, sorry, capital E of X minus, we can write here mu or mean or average, anything is fine. Fine. What I do is, I'll write here mu. Okay. So this is nothing but mu equal to E of X. And then here, second moment, how can we write the second moment? Okay, let me delete everything. So how can we write the first and second and third? So here, we can write the second business moment using the first business moment formula. And the second business moment, we can use it for the third business moment. So E of, you can understand, I don't have, okay. E of X is the first business moment. And E of X minus mean is the second business moment. You can write it as square. So X minus mu or average square, you can write it here, square. This is nothing but the second business moment. And coming to the third business moment, E of, we can write here as E of X minus mean or average divided by standard deviation whole cube. This is how we can write the formulas of the first business moment, second business moment, and third business moment. So here, if you observe in the second business moment, we are using mean, and in the third business moment, we are using the standard deviation. This is how the formula comes for the standard deviation. what this formula is talking about. Let's see what this is talking about. So here, this is the third moment business decision. This talks about symmetry in the distribution, and mathematically we can give it as E of x minus mu by sigma whole cube. E of x minus mu by sigma whole cube. And what else? Negative skewness implies mass of the distribution is concentrated on the right. What is this mass of the distribution, like present on the right and present on the left? What is this one? So here, whenever you are calculating the skewness using the formula present there, if the skewness value is equal to 0, then we can call the data is normally distributed, which is normal distribution. For suppose, if your data or when you are calculating skewness for a column, if the skewness is greater than 0, then we can tell the data is not normal. Data is not normal. It may be either positive or negative. When it comes to greater than 0, this is called as positive skewness. This is called as positive skewness. Fine. When greater than 0, that is called as positive skewness. Then what about the negative? When the skewness is less than 0, then the data is here also, the data is not normal. And this we can call it as negative skewness. This we can call it as negative skewness. So what is the difference between normal distribution and positive skewness and negative skewness? How can we talk about this one? So here, let us see the charts, how it is going to look like. So for suppose there is a data present like this. There is data present like this. Within this data, if we plot the chart and I got the curve like this. Now we can call this as normal distribution. Why? Because the data is cut across the average or the mean so that the left and the right part are symmetrical to each other, which is the same. That's when we can call it as normal distribution. When we will call it as normal distribution? When the skewness is 0. When the skewness is 0. Now what happens when the skewness is greater than 0? So when we plot a chart and we got positive skewness, which means the curve is having more towards the right side. The curve is inclined more towards the right side. So I will just plot the chart here like this. So here I am having a tail on the right hand side. So when I am having such type of distribution of data, which means the tail having on the right hand side, which means more concentration of values are present towards the left, only less concentration of values, the higher values towards the right. This is how we can understand the positive skewness. And what about the negative skewness? This is the reverse of positive. When you are having a tail on the left hand side more and the remaining everything else is normal, such type of distribution of data is called as negative skewness. So when it is 0, it is normal distributed. When it is greater than 0, it is positive skewness. When it is less than 0, that is called as negative skewness. So this is nothing but symmetrical across the mean. And these two are different cases. The tail towards the right and tail towards the left. You can see it in the like a chart when we plot it. Before going into that, we will see what is present over here. Okay. So histogram of work experience. So work experience, you already know it is present in education data set. So here they plotted a histogram for work experience and frequency. Now what it is showing chart. So when you plot or when you draw a chart or graph like this, it is indicating the tail is present towards the right, which means the skewness is greater than 0, which is positive skewness. So we will plot a histogram in that particular RapidMiner studio, and we will check whether the work experience present in the education dataset column is having positive skewness or not. Okay, so let me clear the drawings. So I'll go back to my RapidMiner studio here. And here we are using the same data set, which is this particular data set, which I have imported education data set. Now within this, what I have to do, I have to find out the skewness of a column. Okay, so now What are the columns that I have? This is about this one. Okay, fine. So in design, I'll go over here and I'll go to data and I have all these things present. We are talking about the work experience, right? So what I do is I will select only that particular column. How to select only particular column to include or exclude? You have to use the operator, select attributes. Select attributes, I have dragged and dropped it over here in the process. Now I want to select what is the like a column present here, the work experience. So I will plot a histogram for work experience. Okay, let's check it out. So here I have to first make the connection between the data. Output of the data should be the input to the select attributes. And after that, you have to customize your select attributes operator using the parameters. In the parameters, I'm including the attributes, which is only one. What is that one? Work experience. So I got it manually. So this is done. Now I have to establish the connection between the output and also response. When I'm done with all of these things, I have to execute my process. So what did I do right now here? Here I have just imported or used or read the data, which is education CSV file. In that education CSV file, I'm having 3 columns totally, which is data serial number, work experience, and GMAT scores. Out of the 3 columns, now I want to see the skewness of only one column, which is work experience column. So whether it is having positive skewness or not, I want to check it out. For that, what I have done, I've selected one more operator, which is select attributes. Using that particular operator, I've selected work experience from my table and I will execute the process after establishing all the connections properly. I'm executing this one. You can check it out. The work experience, I got only the work experience. Now I want to find the skewness. How to find the skewness? I have to use the operator, extract aggregates, drag it and drop it here. And you have to establish the connection. And you have to establish this connection. And after that, you have to customize this operator using the parameters. So extract aggregates, I want to check only one column is there. So no need to check it out. So I want to find out only skewness. Remaining else, I don't want to have an understanding right now. So I want to check it out, the skewness. So skewness is fine. Remaining else, I don't want anything. So I've checked the skewness and I will execute this particular process. Now the skewness is greater than 0. You can observe here the skewness of work experience column is greater than 0, which is nothing but positive skewness. So what we talked about skewness, if it is equal to 0, then it is normal distributed. If it is greater than 0, that is positive skewed. If it is less than 0, that is negative skewed. So here, when we are taking the work experience column in education data set, I am getting here the value of skewness greater than 0, which is nothing but positive skewness. When I plot a chart for this particular data set of having work experience column using the histogram, I should get a tail on the right hand side, just like this particular one. Here you can see the histogram of work experience. The tail is on the right hand side. So what to do? Can you plot a visualization for this one? No, it will not make any sense. What I do is I'll go back to the design view. I'll remove this extract aggregates. And now I'll execute this query or the process again. I got the work experience. So now I'll go to visualizations and I'll plot here a histogram. This is the histogram for the work experience column. You can check it out here. There is a curve coming and a tail on the right hand side. This is indicating here the positive skewness, which is nothing but most values are concentrated towards the left and less number of values are present towards the right. This is what the understanding that you can get from this particular histogram of work experience column present in education dataset. This is nothing but right skew. Now, what is there? What is the other thing present in this particular slide? Let's see. So here there is a second one, which is plotting a chart, which is a histogram of GMAT scores column present in education dataset. Here, when you draw a curve, you can understand there is a small tail present on the right hand side. So this is not as much bigger tail as work experience. There is a long tail over here. but this is a small one. So we can like when you're having such type of cases, you can't see the chart and tell whether it is negative skewed or whether it is normally distributed. So that is why you will have to plot, or you will have to just find out the skewness value. If it is less than 0, that is negative. If it is greater than 0, that is normal distribution. Now we will check out the histogram of GMAT scores or GMAT column present in education data set. Let me clear the drawings. I'll go back to this RapidMiner studio over here. Now I have got work experience histogram, positive skewness. I understood properly. Now I want to talk about GMAT scores. I want one attribute which is GMAT. Okay. So I want to execute it. Now I got the GMAT scores. Now we have to understand whether this is having positive skewness or negative skewness. So I have to use again the same thing, which is extract aggregates. I will check it out, and you have to establish the connections properly and the output to the response. Everything after establishing, you have to check whatever the aggregations that you want. I want to check only skewness. I don't want remaining else. So I will uncheck everything others, and I will take only skewness value. So I want to check the skewness of GMAT column present in education data set. So read CSV will read my education data set, will import it, and select attributes, will select the columns. Here I'm selecting the column which is GMAT, and the third one, extract aggregates. It will just extract the aggregations within which I have chosen only skewness. After this, I'll have to execute this process. After executing, you can check it out. This is negative skew, which is nothing but the skewness value is less than 0. For GMAT, there is a small tail you can observe here in the histogram, right? In the histogram that we have seen here, there is a small tail on the left-hand side, which is indicating the skewness is negative. But in some cases, even the tail is very small, it will talk like the data is normally distributed. So that is why instead of looking at the chart and making the insights or getting the information, you can find out the skewness value and understand more. So work experience is positive skewed and GMAT is negative skewed. When I plot a histogram for this, in order to plot a histogram, we can't plot it directly with the help of extract values. We have to remove the extracts, the aggregations. After that, we have to plot it using the histogram. We are having a single column, so no need to do anything. So you can observe the tail is present on the right side. Sorry, the left side. The tail is present on the left side, which is indicating here the skewness is negative. This is how we can plot the histogram and understand the symmetry of the distribution with the help of the third movement business decision, which is skewness. So skewness talks about the asymmetry of the distribution. If the skewness is equal to 0, then the data distribution or the data is normal. If the skewness is greater than 0, then we can call it as positive skewed. If the skewness is less than 0, we can call it as negative skewed. And in this RapidMiner studio, you can plot the charts very easily by just going to the results view and going to the visualizations part and selecting the chart. You don't need to write any code just like Python. That is why this is very useful for any user to write or to derive the insights from any vast amount of data. So this is about the third business movement. Let's go back to our slides and see what is there. Okay, fine. Now what else? So third movement business decision, you have positive and negative skewness. So negative skewness is nothing but here. So negative skewed, normal skewed, and positive skewed. Fine. So negative skewed, which is nothing but the tail is present on the left side. And here, the mode will be greater than median, will be greater than mean. You have to understand these points. So mode in, like when you are plotting a chart for a column, if you got the skewness value, which is less than 0, that is called as like a negative skewness, which is nothing but the tail is present on the left-hand side mode. And then here the mode will be greater than median and median will be greater than mean. When you go for normal distributed data, the skewness is always 0. So there is no skewness. And here the mean will be equal to median will be equal to mode. So the normal represents a perfectly symmetrical distribution. And whenever the tail is more towards the right hand side, then that is called as positive skewness. And here the tail will be in positive direction. And here, this is the opposite of this. Here the mean will be greater than median and median will be greater than mode. This is how you can understand the third moment business decision, which is skewness. So we have seen the first moment business decision, which is measures of central tendency. And the second moment business decision also we have discussed, which is measures of dispersion. The first moment is having mean, median, and mode. And the second business moment or the second moment business decisions is including variance, standard deviation, and range. And the third one that we have is skewness. We have seen each and everything how to do it in RapidMiner Studio as well. We have one more business decision or business moment left out, which is the fourth moment business decision. So the last one that we have is fourth moment business decision. This is also called as kurtosis. The fourth moment business decision is also called as kurtosis. So kurtosis basically talks about the peakedness of a distribution. The peakedness of a distribution, just like that I have mentioned before, the formulas. So the first moment business decision is nothing but E of X, and the second moment business decision is E of X minus mean whole square. Okay. Oh, anything is fine. Now we can call the third one E of X minus mean divided by standard deviation whole cube. Oh, sorry. Now we have one more business moment left out, which is fourth business moment. How can we write the formula for fourth business moment? So the formula for fourth business moment, we can write it as E of X minus mean divided by standard deviation whole power 4. This we can call it as the fourth moment business decision. So the fourth moment business decision is kurtosis, and fourth moment business decision talks about peakedness of a distribution. And also, as I've told, this is 1, this is 2, this is 3, this is 4. These are the squares that is increasing one by one for each and every business moment. There is something like in the formula, they will write which is 4 minus 3. So I'll talk about that one as well. So before that, we'll move on to what is present here. So this is the fourth moment business decision. It talks about the peakedness of the distribution, and mathematically it can be given as X minus mean by standard deviation whole power 4 minus 3. So here, how can we talk about the kurtosis? How can we talk about the kurtosis? So when we are calculating the kurtosis, when it is equal to 0, or equal to 3, then it is called as normally distributed data. We can call it as normal distribution. When the kurtosis is greater than 3, that is called as positive kurtosis. Now, if your kurtosis is less than 3, then it is called as negative kurtosis. So, when we are talking about the skewness, we have skewness equal to 0, skewness greater than 0, and skewness less than 0. But in this case, we have some other thing which is different. Kurtosis equal to 3, kurtosis greater than 3, and less than 3. So, based on this, we will calculate or we will see whether it is having normal distributed data or it is positive kurtosis or it is negative kurtosis. We will understand. So, how to understand these things clearly? So, when we are plotting a chart, so when this chart is looking like this, for suppose this is normal distribution. We already talked about normal distribution. You know normal distribution. So that is kurtosis equal to 3. When it is greater than 3, how it is looking like? It will have. So you can just observe. Okay, you can understand this more clearly when we move on to the mind map. So let us go to the mind map here. So we have discussed only measures of dispersion. Let's check it out. What is present for skewness? So in skewness, you have negative skewed, which is also called left skewed. and positive skewed, which is also called right skewed. And here, if skewness equal to 0, then it is normal distribution. Okay, we have talked about skewness, fine. Now you have the last one, which is fourth movement business decisions, which is called as kurtosis. Kurtosis is of 3 types. When equal to 3, it is called as mesokurtic distribution or normal distribution. When it is greater than 3, it is called as positive kurtosis. Positive kurtosis is also called as leptokurtic distribution. And the last one that we have is kurtosis less than 3, which is negative kurtosis, which is also called as platykurtic distribution. So when it is negative kurtosis, so when your chart is looking like this, so when it is negative kurtosis, you will have thinner tails and wide peak. What is it? So you will have thin tails. Just a second. You will have thin tails and wider peak. The peak will be wider. And here the tails will be thinner. This indicates negative kurtosis. And what is positive kurtosis? So positive kurtosis is also called as leptokurtic, and negative kurtosis is also called as platykurtic. And normal distribution is also called as mesokurtic. Now, when you are having positive kurtosis, you will have thick tails and sharp peak. So you will have very sharp peak and very thick tails. This will be the indication of positive kurtosis. This is how we can understand the kurtosis with the help of chart. So in order to make it equal to the skewness, which is equal to 3, greater than 3, less than 0, it is not equal to skewness. This is indicated with the help of 0. This is indicated with the help of 3. So in order to equate these two things, there is one more concept called as excess kurtosis. That is why in the formula, it is written as E of x minus mean divided by standard deviation to the power 4 minus 3. So this minus 3 will indicate excess kurtosis. This minus 3, this formula will indicate excess kurtosis. We are subtracting 3 from the normal distribution. This is called as excess kurtosis. And what else are there? So skewness, kurtosis, how to calculate the kurtosis in RapidMiner Studio? We'll check it out. So we'll go back to our RapidMiner Studio here, and I'll go to this design, and I will just select the attributes here, which is, I will select subset, and I want to choose here GMAT and work experience. I want 2 columns, and I want to check what is the kurtosis of both of those columns. So I have used again the education data set. I'm not changing anything. And in this selection of the attributes, instead of selecting a single attribute, I have gone for a subset. So subset means I can select as many attributes or columns as I want. In that, I have chosen 2 columns. One is work experience and second one is GMAT. And after that, I have to create, or I have to find out the kurtosis values. So I have to use here extract aggregates. So I'm checking this using extract aggregates. After that, what I have to do? I have to choose which aggregation that I have to find out for those columns. So I have to find out for all the columns present here, I want to find only the kurtosis. So I'll remove everything else. And I will take only the kurtosis checkbox. So CS3, I'm selecting the attributes and I'm extracting the aggregates, which is kurtosis. Based on the values, I will understand whether it is having positive kurtosis or negative kurtosis. So I'll just click on this one. So see, if you observe, the work experience is greater than 3, which is nothing but positive kurtosis. And this is less than 3, which is negative kurtosis. So what did we see about positive and negative kurtosis before? So when we go back here to the mind map, you can observe negative kurtosis is wide peak and thin tails. Wide peak and thin tails. So we will observe in the histogram of GMAT. Why? Because this is having negative kurtosis. So let me remove what I have written here. So I'll go back to here. I don't want to get the extract aggregates here, and I will execute this one. And then what? I have to create a histogram. So visualizations. I will create a histogram for what is the column that I want. I want to have the column which is GMAT, not the work experience. So I'll select here only a single attribute. Okay, fine. This is also fine. So I have two columns. One is GMAT and second one is work experience. GMAT is having negative kurtosis. Negative kurtosis is nothing but it should have a wide peak and thin tails. So here, if you observe our histogram, you can check out the bins also. For suppose I will check it out, maybe 10. So based on the bins, your chart will look like. So this is having the skewness, which is, what is the skewness? The tail is present on the left side, which is left skewed, which is nothing but the kurtosis value. You can understand whether it is positive kurtosis or negative kurtosis. I'll go back to the design and I'll use again the extract aggregates and I will check everything, the skewness and kurtosis, and I will understand whether it is positive skewed or positive kurtosis, negative skewed or negative kurtosis, or normally distributed data. Skewness and kurtosis for both the columns. I did not establish the connection properly, so establish this properly and also select this and check it out to response. Now, if you observe for the GMAT column, the kurtosis is less than 3, that is negative kurtosis. And here, this is also negative skewness, which is the tail is more towards the left side. And this skewness is positive, and the kurtosis is greater than 3, which is also positive kurtosis. This is how you can just understand the concept of asymmetry of the distribution, whether it is normally distributed data or not, and what is the peakedness of the distribution from the kurtosis. You can understand it in RapidMiner Studio with the help of extract aggregates operator. So you can understand mean, median, mode, average, standard deviation, and you can also understand minimum, maximum, kurtosis, skewness, everything from a single operator present in this RapidMiner Studio, which is extract aggregates. So that is why you have to understand the description of every operator so that it is easy for you to understand or to use it in this particular RapidMiner concept. So here, as I told, in order to get the description of every operator that you're using, what you have to do, you have to right click if you want it, right click and get the description, or hover your mouse button, you can get the description. Anything is fine. Under this, you can find the input, your output, the parameters present, everything you can understand here. This is how you can understand the concepts of everything in RapidMiner Studio with the help of description. So when you want to create or save the charts, I've told you how to save the charts, right? So you go over here and you will have here the charts. You can save the charts as whatever the format that you want. Okay, these are the 4 business movements presents. Like 4 business movements like what? Measures of central tendency, measures of dispersion, and then the 3rd business movement, skewness, and the 4th business movement, which is kurtosis. So 1st business movement talks about mean, median, and mode. And 2nd business movement talks about standard deviation, variance, and then range. And the 3rd one we have is skewness. And the 4th one that we have is kurtosis. And what else is there in the slide? Just check. We will check it out. So we will go back here. So here you can see this is nothing but positive kurtosis. Here you can see there are long tails and the peak is very less. Here you have wider peak and the tails are thin. That is negative kurtosis and positive kurtosis. Next, you have one more important concept, which is box plot. So let's discuss about the box plot in today's session, and whatever the topics that are left out, we'll talk about those in the next week session, which is on the next Saturday. Okay, so box plot, what is box plot? What do you mean by box plot? So box plot is also a univariate plot. What is it? Box plot is also a univariate plot. So what is the purpose of a box plot? Box plot is useful to find out or to detect outliers. It is used to detect the outliers, and this box plot is also called as box and whisker plot. Why, we will see in this particular chart that is present in the below. Okay, box plot is also a univariate plot. Box plot is useful to detect the outliers, and this is also called as box and whisker plot. Okay, this is also called as box and whisker plot. Now we will understand how we can detect the outliers. How we can detect the outliers using this particular box plot. Okay, so here we will see what is present in the chart. So this is the box plot. If you observe, this is Q1, this is Q2, and this is Q3. Q1 is nothing but the first quartile. Q2 is nothing but the median. Q3 is nothing but the third quartile. And what is that? This is the minimum, this is the maximum. And here if you observe, there is a whisker present over here and also another whisker present over here. Because of the presence of whiskers, you will call this as box and whisker plot. Because of the presence of whiskers, you will call it as box and whisker plot. So how can we detect the outliers using box plot? Just let me let us like a fine. So here, if you observe the chart over here, in the box plot, how can you detect the outliers? We will see. So here, whatever the data or whatever the data points which are present below this minimum or present above the maximum. So you already know about the box plot. We won't talk very deeply into the topic. Just we will see what is box plot and how it is useful for us. So this is univariate plot. It is useful to detect the outliers, and it is also called as box and whisker plot because of the presence of whiskers, and whatever the data points that are less than this minimum value or greater than the maximum value are comes under outliers. So the minimum can be found out, we can find the minimum value with the help of the formula, which is Q1 minus 1.5 into IQR. And the maximum is Q3 plus 1.5 into IQR. So whatever the data points which are less than Q1 minus 1.5 into IQR, those comes under outliers, which is called suspected outliers, and which are greater than Q3 plus 1.5 into IQR, those also comes under outliers, which is called suspected outliers. So whatever the data points that are less than Q1 minus 3 into IQR, those are called as outliers, and which are greater than Q3 plus 3 into IQR, those are also called as outliers. So based on this formula, you can find out whether there are any outliers present in your data or not with the help of a particular chart called as box plot. Okay, so here let us take a small example and we will close the session. So here, let me take a small example here. I have data points 10, 10, 20, 30, 40, 50, 60, and 700. Okay, I have an outlier present in my data. So imagine, say there are totally maybe 7 values present, right? So the center value I will indicate like Q2, which is median, or the second quartile. Here I will take it as 40 because that is the center one. And I will take here the Q1, which is equal to 20 because this is the center part of these 3 values. And I will take the Q3 as 60 because this is the center value of the other 3 values. Fine. With the help of this particular thing, I have to find out whether there are outliers present in my data or not. So outliers, what did we talk about? Whatever the values which are less than Q1 minus 1.5 into IQR, those comes under outliers. So we will check first of all IQR value. So IQR is nothing but Q3 minus Q1, which is nothing but what is Q3 here? 60. 60 minus 20 is equal to 40. IQR is 40. Now what is this one? Q1 is 20. 20 minus 1.5 into 40, which is nothing but 60. So 20 minus 60 is equals to minus 40. So the values, there are no values which are less than 40 here, minus 40. Fine. Now what is the other concept, which is Q3 plus 1.5 into IQR. So what is this one? Q3 here is 60. 60 plus 1.5, sorry, Q3 60 plus 1.5 into IQR, which is 1.5 into 40 again 60. So which is equals to 120. So you can see or you can observe there is one data point in our data set which is greater than 120. What is that? That is 700. So now we can treat 700 as an outlier. This is how we can understand outliers by plotting a box plot. So box plot is one of the univariate plot present, which is useful to detect the outliers in our data based on this concept of interquartile range. You will calculate the outliers. So here I've taken a sample data and I've checked out whether I have outliers present in my data or not. So this is how you can just detect the outliers. And our box plot is having whiskers on either sides. That is why this is also called as box and whisker plot. This is about the box plot. We'll check out whatever the other topics left out in the next week Saturday session. So I hope everything is clear up to here. In today's session, we have started discussing about the steps or various steps that we are about to do when you're working on a project. First one we have is business understanding. And the second we have is data understanding, in which we have data collection and data types. And the third and like a most important one, which is data preparation, within which we have discussed EDA, which is called as exploratory data analysis. It is also called as descriptive statistics or descriptive analytics, within which we have 4 business moments. The first business moment, which is called as measures of central tendency, and the second business moment, which is called as measures of dispersion, and the third business moment, which is skewness, and the fourth business moment you have is kurtosis. So apart from these, we have also seen few charts like bar plot. When we are plotting a bar plot, you may not get sometimes much insights from that chart. So alternative charts, there are a lot of charts present within which we can use histogram. So both all the 3 charts that we have discussed today, which is bar plot, histogram, and box plot, these 3 charts are univariate plots. And also we have seen how to perform all those aggregations by using the operator in RapidMiner Studio, which is extract aggregates, and also how to plot a bar plot and how to just plot a histogram I've shown you in the RapidMiner Studio. And also what else? I've also talked about few operators which we mostly use, like select attributes, extract aggregates, and also sort, sample, all these things we have seen. And also we have discussed what is probability and what is probability distribution. And also we have seen there are 2 different distributions present, continuous and discrete, and what is random variable. And also we have seen inferential statistics. Apart from all these EDA part, we have seen all those topics, and also we have used sample operator in RapidMiner Studio. So everything, it is helpful for you. And whatever the slides that I'm presenting to you, it is present in your LMS within the RapidMiner module. In this RapidMiner module, you got different topics present. So we have seen yesterday this first one, which is RapidMiner primer. And today we have started the second module, which is EDA and graphical representation. So up to here, I hope everything is clear for you. The session is useful for you, I guess so. And whatever the topics that we have left out, we will talk about that in the next week Saturday session, which is again from 9 to 1. So thank you, everybody.
And how can we access to the LMS, ma'am?
You will get the folder by default added to your LMS module. No, it is not present. You can check it out whether that is added for you or not. So in my particular module, this is added like RapidMiner text. Within that, you have go to course, in which you can access every slide present. Okay, if it is not added, maybe I'll ask the team whether there is any process to do this or not, and we will talk about that in next week Saturday session. Okay, thank you, everybody.
Thank you, ma'am.